Welcome to my stream today, and this time I have a little bit less of a plan. The last couple of weeks I've had this big plan that I come in with, and I've got this whole these show notes kind of already started, and I'm trying to just go down those notes. But every single time, two things has happened. First of all, I've ended up not covering a bunch of the things that I want to cover, and so I ended up like copy pasting them and sending them to the next week. And then the second thing is that I end up, because I've got the whole show planned out and I've got everything sort of figured out ahead of time, I end up jumping back and forth and saying, oh, I'm going to cover this later, or I'm going to cover this, in the next section. And it just turns out that's not the best way to do a stream. It's not the best way to record a video. The best way to record a video is to just do the thing and focus on the thing at hand. Also, it makes video editing a whole lot easier later if you're just doing one thing at a time and moving from one to the next. And so that's kind of my plan today. The plan that I have today so far in my head, it's a little bit looser of a plan, but the plan is to start by working with Qwen 3.8 27B. Qwen 3.8 27B is the model that was just released this week. Actually, I think it was yesterday or the day before. And I've gotten it running on my computer, but just, briefly, I haven't gotten it optimized. I haven't really played a lot with it. I did a little bit of just testing. And so I want to, first of all, kind of just get it running quickly on my setup. And here, let me just switch over to, as just a reminder, the computer that I'm running this on is this GMK Tech Evo X2, because I got it for a deal a while back. And it's not the most perfect computer in the world. Like, there's problems with like the Wi-Fi chip that's in there. Oh wait, you can't see this, can you? Somehow you can't see what I'm doing. That's not good. Okay, now you can see. I don't know why that blocked like that. I'll just need to keep an eye on it. But yeah, so this is the GMK Tech Evo X2, and this is the computer that I'm running this on because I got a big deal on it like a year ago. And it's insane to see these prices now because I got the 128 gig RAM version. It's like, that's insane. I think I got this for $1,600 or $14 or something like that. Like, so I just got a great deal. And so this is kind of the nice thing about this is it's 128 gigs of RAM. So if you've looked at the NVIDIA Spark lineup of computers, it's a very similar thing. Here, let's see. DGX Spark. They've got a very, very, very similar thing where, here, 128 gigabytes of unified system memory. And so that means that this isn't VRAM. It's not like directly bolted onto the chip. It's something where you're kind of sharing your system RAM and your video RAM, and you're using a same shared pool for all of that, which means that like a bunch of things matter. Like the speed of your interconnect matters, the speed of your RAM matters, all that stuff matters. Like, we were kind of entering into a regime of personal computing where RAM speed, like, yeah, it was getting faster, but it didn't really matter. But when you're starting to share the RAM for both the system memory and for this, like, these LLM and graphics workloads, you really just need that to be fast. But so the thing with the DGX Spark is that the DGX Spark is NVIDIA. So you can just install the standard NVIDIA stuff. Like, you can install the NVFP4 stuff. You can just basically install all of the NVIDIA specific things that you want, and everything just works. When you start going over to here, the Evo X2, this is this Ryzen AI Max Plus 395, and also Framework computer. Wait, what is it? Framework desktop. This is actually the same. Here, let's see. Yeah, the Framework desktop has the exact same chip in it. Oh, 192 gigabyte coming soon. That's cool. I wonder what that's going to run. AI Max Plus Pro 495. I've never seen that before. But anyway, the current one is, wow, actually also the price is pretty reasonable. But so this is this AI Max Plus 395. This is this AMD chip, and it's basically the equivalent to this NVIDIA chip, but it runs AMD stuff. And AMD stuff is a little different. It technically has a lot of the same capabilities, but the software is quite underbaked compared to the DGX Spark type stuff. And so I've installed this. I downloaded. So here's what I do for my own personal use. For the most part, I use LM Studio. Here, let me install. I don't know what happened to my icon down here, where it's like not the good LM Studio icon. But anyway, what I do is I use this to like download my GGUFs, and it's like just a nice interface for downloading. Like you get a lot of the most recent models here. It kind of keeps it all organized for you. And so when you download something through the LM Studio interface, here, let me just show it. It downloads it to LM Studio right here. And then there's this models. And I just have started dropping all these little scripts in here where I can run llama.cpp things. But for example, like if you go into the LM Studio community, you see the models that I've had downloaded in the past. And it's just kind of nice. It keeps them organized. And here, I'll just go into Qwen 3.8. So you can see it downloads the Qwen 3.8 and it keeps the name nice. It also downloads the mmproj, which is the video encoder. Sorry, the video projections that allow it to read images, the image patches, and interpret those image patches. So you've got these GGUFs. And if you just use normal, here, actually, if you just use normal LM Studio, you can load these things. So let me get rid of this sidebar. So I'm just going to do, let me make this the right size. So I'm just going to load this model, right? And in this case, I'm going to load the Qwen 3.8 27B. And you can choose between like what context length you want to support. By default, it locks in at 8192, which that's not even enough context length to really do anything. Like once you use this model, you see what I mean. But like the thinking alone takes up like probably 16K tokens. So I try and max this out, but if you look at what happens when you do this, look at the GPU usage that happens here. Like as you raise this up, you use way more GPU usage. So it's an important thing. And also like performance goes down too. But I just want to be able to support these longer context things. GPU offload is basically how many of these layers are you going to run in the CPU versus the GPU. I'm going to try and keep them all on the GPU. And it's a little bit of a academic exercise here because the GPU and the CPU and all of that are all on the same device here. This is all one. But then you've got the unified KV cache so that if you're running multiple requests, it's all going to go into one. And then there's a couple of these options here, right? Like with mmap, it's going to try to use a memory map for the file so that when it reads things, it's coming directly from the disk. And then in this other thing, it tries to keep the model in memory. And in fact, what I think is I don't want to leave this on because we're using this unified architecture and we're assigning most of the RAM over to the GPU. I think it's like 96 gigabytes of RAM are assigned to the GPU. So that means I only have 32 gigs of RAM in my system memory. So I don't want this to try and keep the model in memory because there's not enough memory for it, especially if there's going to be 45 gigs. Actually, you know what? I was running this before just fine. I'm going to leave this. I think what's going on is that the model itself can be in memory, but it doesn't try and keep the KV cache in memory. I'm just going to leave this. But then the speculative decoding is kind of interesting because this is multi-token prediction. This is the idea of saying, hey, instead of having the model just output one token at a time, you can have it output 2 or 3 or 4 or 5 tokens at a time. And if it's the tokens that would have originally been drafted one at a time, it can accept them. But if it's different tokens, if it outputs garbage or whatever, then it has to run those manually. And so it's just a way of, at the limit, speeding up performance because every time it generates 2 tokens at once, it's generating the 2 correct tokens at once, then you get a 2x speed up. If it's only half the time generating the correct tokens, then you get a 1.5 times speed up. That type of a situation. It's not quite the same because there's a little bit that gets used in actually generating the tokens. Like, it's not completely free, but it's relatively free. Flash attention is a compression algorithm, or is a different algorithm for representing the KV cache and the attention mechanism, and combining a bunch of those operations into one really fast, really efficient operation. If you turn it off, you could see the GPU goes a lot. It requires more GPU. But we're going to leave that on. That one used to, for a while, this was like experimental in LM Studio, and LM Studio just wraps llama.cpp. And then if you, like, we're lucky that we're running on this computer, so we don't have to quantize this, because 45 gigs is a lot of VRAM, and it's not necessarily easy to just fit this on like a 4090 or something. That's why, like, we're using this GMK tech with the 128 gigs of RAM. But the trade-off is that 128 gigs of RAM, it's not fast, and this is, you'll see what it is. But if we're running on like a 24 gig or a 32 gig chip, we would want to do something like quantizing the KV cache, which has a loss in quality, but also makes it faster and better, or actually allows it to fit on the card. So we're gonna just stick with these kind of defaults right now. The only thing I'm really changing is bumping up the context length, and we'll just kind of like show. I'm just gonna kind of show like what performance is by default. And if you look, it actually loaded pretty quickly. So I'm just gonna kind of like show a sample query here, and we'll see how fast it goes. Hello world, or let's say write a hello world application. Oh, I have to actually select which model loads. So it's not slow, it's not too fast. We'll see once it finishes, it lists the performance. Oh, I guess not. Oh yeah, here we go. 21.79 tokens a second. And this actually says how many draft tokens were accepted. It accepted 84 out of my 160 draft tokens. So that probably means that we're getting somewhere around a 50% speed up from using that draft token. Actually, let's turn it off and let's see. If I turn off multi-token prediction, so this was 21.79 and 50 accepted. I'm just going to regenerate. I'm just curious. It actually almost seems like it might be going faster. I could be wrong. Nope, about half seems like even worse than I thought. It's interesting because when it comes in two tokens at a time, each chunk that you see is a little slower to come in, but it adds up and it goes faster. So that's why maybe perceptually it felt this felt faster, because each token was being streamed in one by one. But I'm gonna get back the multi-token prediction. And then, so this is just LM Studio, right? So LM Studio is basically a wrapper on llama.cpp. Actually, I'll eject this now because I was talking about how I use LM Studio to just grab the files and stuff. But today what I want to do is, before I kind of do much more on this, I want to optimize Qwen 3.8 to run on this machine. And maybe that means not using LM Studio or llama.cpp, but maybe using like a custom version of like a Docker container that contains like a VLLM that works on this this chipset better. So, but first of all, before I do that, I've put together like a really quick I've put together like a little script here that runs llama.cpp's llama server. And this is the settings that I came up with for that server. It's basically the same thing that we were talking about here with LM Studio. In fact, what I'm going to do with LM Studio real quick is... Oh, our server's stopped, so never mind. I don't need to. So yeah, I'm passing in the model directory. I'm passing in the vision projections. I'm passing in an alias. I'm saying which host and port to put it on. I'm saying I want to use the Jinja templating engine. I'm turning on flash attention. I'm setting the context length to 200 to the max. I'm offloading as many layers as possible onto the GPU. I'm using that speculative decoding, multi-token prediction stuff and I'm setting again. You saw here. This draft tokens. I'm just setting this value of 2 using this command line. And then I was looking online and I found that maybe reasoning isn't preserved by default. I'm not sure about that, but I passed in both of these options to just make that clear. So this is just the script that I've got working right now. I've got the latest version of llama.cpp compiled with Vulkan. And so if I start it, you can see this is it's going to basically be the same thing that we just saw, but this time it's running on, what's that? Interesting. This time it's running on llama.cpp. So I'll do the same thing. I'll actually paste the exact same message that I posted. Write a hello world application. Let's see how it does. It's nice that we can actually see the tokens per second streaming. Yeah, so actually pretty similar, 22.76. It's the same engine, and I've pretty much given it the same settings. But what I want to do is, yeah, I could do a little bit of optimization on this and getting those settings better, but actually I don't think that's what I want to do. I think what I want to do is here. So first things first, I'm actually running this now. I want to make sure I want to connect Pi to it, my local Pi. Actually, what I think I'm going to do is use codex. Please update my .json to include what is running right now, which you can find at Qwen 3. What is this? Qwen 3.8 serve. I should have done this before the stream, but actually, you see what I do. I'm not even going to edit the file manually. And that also has a benefit of, I'm not sure if I have tokens in there, but if I'm using an agent to edit it, then the tokens won't show up on stream. So we'll see how this goes. And then what I'm going to do is I'm going to, once we've done, this is like the one thing I'm doing in using codex. After this, I kind of want to try and switch to Pi and use Pi for most of this stuff. Oh, the other thing I have to do before we get too far is I need to turn off my Pi's advisor extension, because last time I was like testing out one of these local models, and I have an advisor extension where it can go out and call out and get help from a frontier model. And like, kudos to the local model for realizing and then being able to do it and doing it. But I was all excited about some of its results until I realized that like a frontier model had been involved in it at some point. Once I scrolled up, it was like, oh, hey, it called out for advice. That's not fair. So I'm going to remove the advisor model, even though like in real day-to-day stuff, it's kind of nice to have that. It's nice to have, like, you're not calling out to a frontier model all the time, but you've got an advisor model and periodically you're calling out to it. And there's like a bunch of setups. Like if you use OMP, Oh My Pi, they've got a built-in one that's really good. In fact, that's probably something we should do at some point, is just like install Oh My Pi and explore it and talk about it, because there's a lot of really good ideas there. There's a lot there. That's why I don't really use it as my day-to-day. It's kind of it's got a lot of ideas and it bundles them all together. And some of them are good, but some of them aren't my favorite. So it's kind of like an all or nothing, you take it or leave it. But I think the good ideas in there are definitely worth talking about and sharing. Also, it's just a really good, like, Pi is too minimal almost at its base state when you just install it. And Oh My Pi has like a curated set of really good plugins that are good. Okay. It's adding the stuff. Enable thinking. That's interesting. I didn't know you could do chat template kwargs like that in the Pi configuration file. Okay. Blah, blah, blah. Let's also make sure Pi's advisor extension is disabled or removed. So this will be a little bit more of a real comparison. Like we're gonna really use the offline. Like if we had lost internet and all we had was this GGUF that we had downloaded. Llama local constrained. Oh, okay. Yeah, I do a lot of work with Qwen 3.5 4B, so it's finding that in there. Okay, it created a little disabled extensions. Fine, that works. Okay. Okay. So let's go ahead and I'm going to go to the Qwen serve thing. And I'm going to say, oh, you know what? This is good. This is interesting. We have a little bit of a bootstrapping problem. But let's just see first of all. Oh, I should run Pi update. Okay, what extensions do I have? Pi web. Oh, I should do Pi update extensions. Okay, so what I just need to make sure that I don't have two. Okay, I have a goal extension, compaction-chain, and Pi web access. Let's do model. Let's find my 3.8, and here's my local. There's 3.8 max. I'm just looking at what ones are available on the. It's funny to see all these 8Bs. And it looks like Qwen 3.8 max has a couple of different options to choose from. But I'm gonna just do my llama local one. Hello world. See how it goes. And so this theoretically should be contacting this. We will see. It doesn't seem like it's working. Oh, there we go. Okay. And I bet if I did it again, it would be faster this. Yeah, okay, so it's all primed and ready to go. Okay, and like, it's not slow. It's reasonable. I wish it were faster, but it's not like the worst. It's reading all these files. I just said hello, world. What are you doing reading my files in my directory? Okay, it's giving me a cute little message. Okay. I would like to embark on a quest to get the best performance on Qwen 3.8 27B that is possible on this hardware without massive quantization or damage to the output. Please, actually, so I do have access to, what did I say? Pi web access, which has, I think, connected up my Brave instance. So let's see. Let's see what it can do. Please look up the latest VLLM that supports the AMD Strix Halo 395 Plus chip that would support identical to Qwen 3.6 27B. The cool thing is that Qwen 3.8 27B is literally the same architecture as Qwen, here I'll say identical architecture. Also, look up any dflash or what is it? Oh yeah, I already looked at this. But it's dspark. For larger for batched multi-token prediction. Tell me what all the options are right now. Let's see if it can look up my tool set, look up that I have Brave, and let's see if Brave has a page indexed for a recent thing about this. So the idea that I want to do is I'll probably, like at some point I'll flip this model off. I'll turn this model off. And then you know what I'll do while this is going? I have a desktop computer that actually is running a version of Qwen 3.8 27B. And so you can see it's the same LM Studio setup. But in this one, I'll show you what I had to do. So this is a 24 gigabyte card. And to make it fit on this card, I had to do a bunch of stuff that I wouldn't have rather done. First of all, I don't know why that. I wish that like when you change something, let's say you change it to 3 and you change it back to 2, if it realizes that it's the exact same settings, I wish it would just remove this, but you have to like click delete. Anyway, that's neither here nor there. Where am I? Where am I? So, what I had to do for this one was I could not get the 2000 or the 262,000 token context window. I had to bring it down to 100,000. And even to get it to 100,000, I don't know why this is saying GPU. I don't know why this is saying here. One sec. Let me eject this. Yeah, GPU 23. That's close because it's a 24 gig card. And oh wait, I need to make sure you can see this. Also, I should probably just make myself smaller. So yeah, this is the I'm over on my desktop machine right here, and this is that 24 gig card I was talking about. And so yeah, I've had to make it 100,000, and I am able to offload everything to the GPU, all the layers to the GPU. If you have to pull this back, you start to really lose on performance. So there's that. I brought the number of concurrent predictions down to 1. So that means this machine can really only just handle 1 request at a time. And this is standard. I am doing the standard speculative decoding thing. I'm trying to keep all the GPU stuff in memory. But here's the main thing. I was talking about this before. You have to quantize the KV cache. If you don't do that, look, we're at 28.89 gigs just for 100K. And yeah, I tried it at first where I brought it down. I was just left everything unquantized and brought this down to like 45K. It works, but fitting everything in this context window limit is really hard, especially with this model, which really likes to think. It takes up 25K tokens or something, 16K tokens out of this just for the thinking portion. So let's put it back to 100,000 and let's turn on quantization. And we just have to accept the damage. We just have to. But let me load the model. That means that it's just not going to be quite as good. It's not going to be quite as fast. Or it will be fast because we're keeping everything in RAM, VRAM. But it won't be it will make mistakes. It will miss things in the previous parts of the context. Quantizing your KV cache has a bigger effect than you would want, unfortunately. So let's go ahead, and this parsec stuff is just like a window into the other computer. Let's see where, we're still working on this here. Okay. First of all, it said, it did find search. So it said, let me do some research. It needs to find this. It ran these queries, which is cool. Great, got a lot of useful information. Finding blog posts. Yes, I've definitely seen this repo before, which has got great stuff. I wonder if it's going to find, there's this thing called the rock. Good initial haul. Let me pull the key sources for details on the exact VLLM questions, D-Flash engine support, and DSpark availability. Okay. AWQ4. I haven't seen an AWQ. I guess there's auto AWQ. Let's see what this is saying. M5 Max Qwen 3.8 27B benchmarks. BF16 MTP. So this BF16 is like standard versus the AWQ. But where are they getting the AWQ? Let's see what this says. Okay, what they're seeing is a 4-bit dense plus a native drafter. Interesting. Okay, this is still finding stuff. Let's see what it found. Get content. Oh, that's interesting, actually. I didn't know that upstream VLLM does not natively support GFX 1151. Yes, the rock. It found it. I was wondering about that. It was going to find that. Let me show you the Rock'em. Because AMD's toolkit that's similar to CUDA is called Rock'em, ROCM. And so this is the rock, I guess. And this, in the past, I've had pretty good experience with the rock builds. Of course, like every time I go here, I find something that's like build is broken. It's just always janky. AMD machine learning stuff is always it's a trip. But the idea is they have they have good VLLM. This is like good ROCm installations. I think the Rock has VLLM. Oh no, I guess it's just the ROCm version, and then VLLM uses it. Check in on this. You can see it's a lot of what starts to happen when you do these searches is it does a search, which is fast, and then it goes and it finds the results, and the results might be a lot. Like if you look Control O, well, okay, that wasn't too bad. But depending on how much text gets sent back in, look at how long it takes just to like do the prompt processing. Prompt processing ends up taking a long time. This is like particularly slow though, right here. I don't know what's going on. It's really going slow. I wonder if what we're being shown here, like it maybe, oh yeah, when I Control O, it seems like there's more even. And so that's why it would take so long for the prompt processing, which is getting close, 99%. Okay, here we go. Prompt is finished processing. Now it's going to start outputting. Ketchup. What was my brief? Okay, tell me what the options are. While this goes, I want to make sure that I have a Pi version that, let's see, it was, okay, I have this, I'm going to do one more change. I'm going to use Codex to make one more change. Please update my Pi agent models.json to also include a version of Qwen 3.8 27B that is proxied by a model relay and has a max context of 100,000. So the idea here is I have this little service called model relay, and it allows me to like basically connect up any of my local machines that are running models, and then I can just provide this little model relay API key and URL, and my model relay proxies that to the model. And the cool thing about it is that it's got all these features. Like if I have like 5 different machines all running like llama.cpp, model relay will just kind of round robin across all of them. And then also another feature that's kind of cool is that it will even do things like it will hold the request and wait until the LLM relay starts up. And so like it can basically sit there and wait for a request, and then I boot up a server, I launch it, the request goes through, and it is serviced. So you can do cool things like on demand turn on and off your inference. And I'm not using it for a whole lot of stuff right now, and it's a little janky. I need to make it better. It's vibe coded. It's like a it's like a Claude 4.1 vibe code or something like that. Anyway, so let's try it. Let's try Pi. I've got this 3.8 27B. Hello world. And now this should be running against my desktop, and that was a lot faster. You saw we got prompt processing. Like this actually was a lot faster. But remember, this is degraded. It's like a degraded version. So now I've got this version that's running locally, and I've got this version that's kind of proxied through model relay, and it's running on my desktop elsewhere. And that means that like if I want to take this one down, we can switch over to be Qwen only still, and we'll use that in the in-between time when we're like working on stuff here. Interesting. Found a Reddit thread. MTP or dflash. This is fun. This is actually doing all of the things that I wanted it to do. It found, first of all, like I wasn't even sure if it was going to use and find my Pi Web Access extension. It found that. It's writing reasonably good queries. It read my existing server. It figured out that Strix Halo GFX 11151 support, which is Strix Halo 395 Plus, is not supported on VLLM. It found the separate version that does work. which let's see if I found it. Yeah, this like basically these forks here that do support it. It's looking up dflash and dspark to try and figure out if there's anything there. It's digging in. It checked out that repo and it's looking at the README. That's cool. I've found solid information. Okay, so it's really getting down to like this deep dspark stuff. And the cool thing is here, with the setup that we have, I am not quantizing. We are not quantizing that KV cache. Now, what I will say is that this is all a quant. This is all a 4-bit quant. When we look at the, like what model we're actually serving, it's a 4-bit quant. So that is one area where actually what's cool is on this device, if I were to download the full BF16 weights, I could run it on this device. There's enough RAM on this device. But then as we start to get to like that 24 gig chip on the other computer I've got, that's not good enough. I can't run anything but a 4-bit quant there. And also there's diminishing returns on a quant. In fact, I thought I saw a really good image about this. Let me see if I can find it real quick. Actually, let's look at local llama. I think it might be there. Here. This is exactly what I was looking for. So this is a kind of a cool graph because it shows you like the actual damage that comes from quantization. So like at this point, 32 gigabytes is like the unquantized version of it. Actually, let's see. Let's see what the unquantized version is. Oh crap. I have to sum this up in my head. Actually, let's use this. I'm going to use my, hey, that was fast. This is fast when we're serving it through the, on my 4090 GPU. So already, this is already a quantization because it's actually 55 gigabytes. Let's see. Did I grab 2 of them? Let me just double check. This is just the model. So yeah, the real full fat weights are 55.57 gigabytes. And so when we're looking at this, because that makes sense, this is a Q8 quant. So already, like if we're quantizing down to 8 bits with like the least destructive type of quant, already, like, because 0, the bottom of this line is KL divergence versus BF16. So BF16 represents the bottom of this line. So already you're going from 50 down to 31 or something in terms of gigabytes just from doing this Q8KXL. Then when you start getting down to like, this is the standard Q8. When you see a Q8 version of a model, this is what you're going to find here. And it's going to be 28 and something gigabytes. But look how close. And this looks like a logarithmic scale. So 0.0005 is a very, very, very low divergence level from the standard baseline. And the standard baseline being the full Qwen 3.8 27B. The cool thing is you can run this version. You can run the full Qwen 3.8 27B version, which is cool. But then you see as it goes up. So Q6... when you're doing, like, this is LM Studio's Q6 right here. Q6, if you look at, this is only 0.002 KL divergence value away. So that's also very close. Like, that's a pretty, if you can, in my opinion, like, obviously if you can run the full thing, if you can't run the full thing, run the Q8. But I think the Q6 is kind of an underserved market. Like, Q6 is where, if you look at this, we are almost standard. We are almost like getting the exact same results as we would with the full one. But now the one that I'm running is right here, Q4KM. This is, you can start to see we're not at 0.002. We're an order of magnitude more divergence here. And divergence is bad. Like divergence means that it's not doing the same things that the full model would do. It's diverging from that. And then you can see as it goes further and further and further. And down here, these are these literally these 1-bit quants where, and look at this, isn't just like 0.004 or 0.04. We're talking 0.4. This is like very, very bad at this point. So yeah, you've got a model that runs in 9 gigabytes, but you still, like, I don't know how useful this would be for anybody. I think like as it starts to get up to this portion, like when you get from 2.02 up, it starts to be the type of thing where instead of doing this, you want some other type of, you want to do some other type of thing. Like what you can do is start to look through the layers and delete layers of the model and literally delete the weights of the layers and then train back the performance back. And that's like, it seems like maybe a more coarse weight way of doing things, but it's actually a pretty good way. See how we're doing here. This is still going. I should have probably used my faster GPU on this one. Reddit is blocked. Interesting. I didn't know that. Very good. Next I'll need the contents. It really likes this Reddit thread. Let's run these in parallel. That's cool. This is like this reasoning is very interpretable and very understandable and correct. Like it's doing the right things. Sometimes reasoning, I find in the newer models, starts to get a little bit harder to read because it's kind of more for itself than for the end user. But this is pretty good. Okay, fetching 3 URLs. It's saying, hey, we can use DSpark if we need. And there is a draft model on 3.6. It said, let's fetch this. I don't know. Although, I wonder if you could use the 27B DSpark. I mean, you wouldn't accept all those tokens, but somebody's got to be training a new DSpark. Yesterday, yeah. Yeah, it just wants to learn more about DSpark first, and like the Qwen DSpark. Note, the DSpark head is for Qwen 3.8 27B. That's true. It's this DSpark might actually be compatible, but let me actually just see, just like if there. Here we go. I'm just gonna say note 1.36B parameters SGLang. It could be that SGLang is the one to do on this. This is tough. Our input tokens per second aren't so bad. Or our output tokens per second, like, this is reasonable, but it's the prompt processing. That's just not fast enough. That's just not fast enough. It's like only 4 times faster than output. That's what's tough, is so that this goes and it finds like a big file, it puts it into the context, and then it has to sit here. And also, I don't know why this is taking so long on these things. Like, that's not, this incompatible find options and get like, this should have been, oh, I guess it's this, all these characters that are getting shown. I think it's showing more to the context than it's showing to me. Like when it does these ellipses here, I think that's more stuff that's going into the context. And that's why we're sitting here waiting on prompt processing. Close though, getting close. So while this goes, I actually have another thing I want to do. When I'm testing out this stuff, I want to create, so okay, here's the thing. I find that when I do when I say like maximize performance of something, an LLM, when you don't give it anything, it will do really, like if it's testing in an LLM output, it will do really simple queries like 2 + 2, 2 + 3, 2 + 4, and it'll do these really, really, really tiny queries, and it'll optimize for that. But the problem is that that's just not really a realistic depiction of what we do with these models these days. Like if you look at what I'm doing with this model here, it's an agentic workflow pattern where like I typed in something, it's like doing multi-turns. Each turn has reasoning that is cached and then resent back. There's just like a lot of stuff that's going on that's different than a hello world. So what I want to do is actually create a little proxy that captures the traffic as it's going to the LLM. Like as it's going out of Pi and into the LLM, I want to just have a little proxy that captures that traffic and then saves it, like saves it somewhere on disk, and then allows me to take those saved like in order proxied traffic and replay it and see, okay, are we making a real use case that we're really doing faster or slower? So I'm going to just start on that right now. I'm going to start a new Pi session, and I'm going to use the one that's proxying to my desktop so it's a little bit faster. And I'm going to say, okay, create a single file Python proxy, Python HTTP proxy for this llama.cpp or LM Studio. I'm just going to say exactly what I basically said into the camera. The idea here is that I want the ultimate end game here is that I want to create a benchmark that is more realistic than standard benchmarks are. I want to put this proxy in between my Pi session and the LLM itself and capture all of the traffic without actually impeding or affecting the traffic at all, and then save all of the back and forth messages to disk somewhere. Then this captured proxy traffic is representative of work that me or my agents would actually do. So the captured proxy traffic could be replayed in a turn-by-turn way or teacher-forced way, and that the output of that replayed traffic could be measured for performance. We would have to think about things carefully because each inference output is different. So if we play the same input message, we should keep track of the number of output tokens and cap so that the replayed version stops at the same number of tokens so as not to skew the results, and then discards the tokens from the LLM under test, under benchmark testing each turn, so that each turn returns back to the captured prefix. Does this make sense? Please let me know if there's anything unclear or needs more thought before you begin. So that was a long prompt, but basically I'm saying I want to create this little proxy. Let's see what this does. It's saying design considerations. The target API, does it expose both chat completions, or it should at least handle chat completions? It might also handle V1 models. It's saying, I kind of want to make sure it does the, like if you look at what this supports, it supports OpenAI compatible responses, chat completions, embeddings, and Anthropic compatible as well. Let's just say I'm just going to copy all this. It's doing a lot of thought. It's still in thought after that first message. So this is saying storing all the, wait, okay. There's a lot. Let's start. Okay, streaming probably uses streaming. Yes, it does. The proxy has to transparently pass through the SSE chunk, simultaneously record the complete request body and all stream chunks. This is a critical requirement. Yeah, that's true. I actually hadn't thought about streaming as much, but that's true. Needs to capture the request headers, the response status, all the metadata. Yeah. Better approach, save a trace file with per turn entries. Okay. Yeah, if you have like a JSON-L file, you just save it out, and then you can reconstruct whatever you want later. Replay teacher forcing. Read the trace file and process each turn in order. For each turn, take the request body. For the replay to be teacher forcing, the request should be the exact captured request. For each turn, take the request body. For the replay... The output of the LLM under test does not affect subsequent inputs. This is exactly what the user said. Yes. This is saying there might be a tokenizer mismatch, but I'm only going to be testing the same model against itself. This is really a performance test, not a correctness or output test, like an output quality test. In no way. Yeah, I like only using the standard library, zero dependency, must handle streaming, handle arbitrary methods. Don't impede. Correct. Don't impede. It's a nice little schema it came up with. Like request packet schema. It's a lot of small objects. That's true. Yeah, it probably wouldn't be better to have 100K objects on disk. Like just one file with 100,000 lines is fine. 100,000 lines seems heavy. This very harness. Okay, this is a lot. I'm not going to go through all this. Oof. Oh, so it's already writing code, sketching the code. LLM PCAP, proxy capture, I guess. Let's check in on this other one. This is still going too. This is the thing with local LLMs is that you sit there and you wait a lot. Hurry up and wait. But let's see. Okay. It's a treasure trove. Now let me check. VLM releases. Oh, and then I gave it this. I gave it the Radix Arc one. And it said, let me fetch this and also grab the content I already retrieved. Yes. Okay, so I think it's on the right track. It's a dense model. Yes. D-Flash draft model. Yes. Okay. Comprehensive overall picture. On Strix Halo, the decode speed is memory bandwidth bound. LPDDR5X 8000, about 256 gigabytes a second. Yeah. Q8, if I could run Q8 at a reasonable speed, I would love that. But if I need to run a Q4, that's fine. Because I'm finding, like we talked about this before, where Q4, our deviation from the full fat is not that much. Like, and by jumping to Q8, we are doing better, but remember this is logarithmic, so where was it? Q4 0.02 versus 0.000. Yeah, it'd be nice if we could run that Q8. I don't think we need to run the full thing, but 4 I'm noticing with 0.02 deviance, it's not that bad. It's pretty good. And if I could run, maybe I could run Q5 km. Bring it down to 0.005. Although I don't know what this AD... Actually, to be honest with you, I don't know what this atomic chat thing is. It must be a proprietary situation of theirs. Okay, so it's doing some searches. This has been the agency of this model and what it's able to do. It's running curl. It's doing searches. It's reasoning about what my system has. It's like writing. It wrote a little Python inline script to get information. Like, this is an impressive model already. It's doing really smart things. And I've got 43% of my context window used. It's going to organize this. And remember, what I asked for was tell me what all the options are right now. What I'm going to have it do is put together like a plan and in like a markdown file. So while I have this thing working on the proxy, here's what I'll do. This is working on the proxy. Once this proxy finishes, I'll do some capturing of the traffic. Like I'll pull up some Pi. I'll pull Okay. So this is working on, while this is working on saving what all the options are, the next thing I'm going to have this do is save a plan. And save a plan and a list of things that it's going to try to like maximize performance. And I'll have it come up with a checklist and stuff. While that's going, this thing is going to finish writing its proxy. Once the proxy's finished, I'm going to boot the proxy up and I'm going to actually use it. I'm going to use it to try, I'll capture traffic for some basic agent operations. And once we have enough traffic, then that gives us our benchmark. And then we'll use the benchmark and I'll say, hey, use this plan that you've come up with and use this benchmark that I've come up with and maximize the performance on this benchmark according to this plan. And whatever we get out on the other side of that, it's going to be interesting. I'm curious what it's going to show. Now, I am a little bit curious about this because remember, this is running on that 100K max context window, and it's also the one that has quantization. So this is the one that might make mistakes. This one right here is less likely to make mistakes, but you can see how slow it's going. Yeah, it's kind of cool to just see them side by side. It's going back and forth. It says, should I really just do standard live only? Standard library only? I don't know. I wish I had HTTPX or AIOHTTP. I don't mind if it wants to use those things. But we'll see what conclusion it comes to. I said single file. I did not say no dependencies. No dependencies would be nice, though. Standard library only would be nice. And you can do what I'm trying to do with just the... You don't need any fancy stuff, just a proxy. Standard library's fine. It's a benefit of a standard library. Okay, so what is this saying? This is everything. It's going to like output this exact same thing. Like this is its thought process, so this is not my output yet, but it looks like it's organizing it ready for my output. So they're saying they've figured out what the latest stable release is. Oh, I didn't know that llama.cpp supported dspark, actually. That's kind of cool. SGLang on Strix Halo. Yeah, I'm happy to use SGLang if that's what they want to use. SGLang seems to be the fastest. VLLM has a little bit more widespread support. But if we can get SGLang running on this, that would be amazing. But running SGLang on this hardware is community experimental. Yes, okay. dspark. Trained with SpecForge, deep spec format. I don't even know about these things, actually, to be honest with you. Okay, so it's finding Strix Halo VLLM options. This is the one that I expect will win. This is the one, this like Cayuse 0, and then the rock version of it. I think I've had good experiences with it before. I've used it before. But it looks like it might be older. Things move quickly in the LM space. So even if it's just a little bit, a couple months old, it might not be the best approach. We will see. I hadn't really thought about using dspark for llama.cpp. That's the other thing. So I'm tossing, like, I don't care if it's llama.cpp that's the fastest, or if it's VLLM, or if it's SGLang, or if it's something I've never even heard of before. I don't really care, honestly, as long as I get correct output and it's the fastest it can be on the things I care about, then that's what let's do. I keep getting scrolled up. Here we go. It's going to do one last verification. It's very careful, this model. Okay, watch. Let's look at the prompts per second. We're getting between 14, 13, 16, 15, 12, 11. That's our tokens per second we're getting. 17. So probably averaging around what? Average around 14 and a half? That's what this is saying. 14 and a half tokens a second. But what really sucks is this prompt eval time. This is prefill. It's not good. This is the thing that kills me. For some reason, I'm much more okay with like output taking a while. Because you kind of like, you see it. That's part of it, is you see the output. You don't see the input as it's going in. Maybe that would be cool, is like as you hit enter, it highlights as the input is finishing its prefill. That might help with just usability, but it won't help with any wall clock times. What did this do? Oh, it wanted to check llama.cpp merge status. Jeez. It's still going. Wait, did this OpenAI responses stream ended before a terminal response set? Is this starting over? I hope it's not starting over. Hurry up and wait, huh? What do you think, chat? Should we talk about something, chat? There's no one here. That's the joke. Oh, cancellation hangs. That doesn't sound good. Okay, it's getting ready to write its final answer. It's giving itself a TLDR in its own thoughts. Yeah, I have to just say again, these thoughts, the Qwen 3.8 27B thoughts, are very readable. It's not like a caveman or anything like that. It really seems to be good output. Let's see how this is going. I don't like seeing these OpenAI responses streams ended because I'm worried that what's happening is it's starting over. I'm worried that it's not picking up where it ended. Because here, specifically, when it got this stream ended, it said, oh, the user wants a single file Python HTTP proxy. And if I scroll up to the very top, the user is asking me to build a single file Python HTTP proxy. Like, I'm worried that what happened is it did all this stuff, all this thinking, and then, oh wait, up here, and then up here, something happened wrong in like the like maybe in model relay or something. Oh, I pasted this. This is when I pasted all the things I want to support, and then it did that again, and it says the user wants this. I'm worried. Let's just see. I'll give it more time. Key questions for the user. Which model endpoint does Pi actually hit? I can check their config. Yeah, please check my config. I don't want to deal with that. Capture format preference. I would say JSON-L log. I would say yes. JSON-L log. We'll see what it says. This is still outputting. Okay, let's just take a look though. While this goes, TLDR. Fastest win 0 setup. You just use what you got right now. Best verified is llama.cpp. I could try using dflash or dspark on the llama.cpp stuff. I think I would like it to try that. So it's saying, okay, we found a good drafter. I'd like to try that. It found, this is the one that I've had luck with. The Rock GFX 1151. And it's saying that it's got dflash and dspark in, but spec decode not verified. That's fine. We'll verify it. Or we could just train our own dspark dflash. That's true. Maybe. Especially if it's a model that's driving it and not like me having to do all the work. So then it's going to go into each one. It's saying VLLM. It supports dflash and dspark, and it supports Qwen 3.8, but doesn't support my graphics hardware. But there's this. There's also this. We might need to like port some of these patches in or something. I don't know. Older VLLM, but it's the reference implementation for it's actually possible on this silicon. Okay. I'll just do Q8. I mean, AWQ int 4. That would be interesting. AWQ int 4 would be very interesting to me. Oh, you know what? Oh, dspark is dflash. Okay. I want you to write out a whole plan.md file where you exhaustively try all these different options in Docker containers? In containers? To keep things sane? Lest they get in the way. And that also includes all the different configurations and trying many different things like MTP draft tokens and token count expectations, etc. Let's exhaustively try everything to maximize perf on this machine. And by the way, I don't just care about single stream, single inference performance. I'm also interested in sub-agent workloads and workflows. That means that overall throughput matters too, not just single stream, single user performance. But let's say batch sizes of up to 6, of up to 8, or 8, let's just say. A document that walks through all the options, all that's available, and has a checklist and a plan for how to try all of it and get the best results possible. Be thorough. Be exhaustive. Make sure this doc is the only doc that needs to be read. Simultaneously, I am having another agent create a benchmark on my real-world tasks, so prepare for that benchmark being available soon. It's not available yet, but I'll let you know the moment it lands. This is still going. Okay, did it reset again? No. Oh, maybe. Okay, real quick, what I'm gonna do is copy this. I wish I had like a better way of doing this. Oh crap. I don't know how to. There we go. I got it. And then I can go right to the source. I'm just cleaning this up a little bit. I'm gonna end up reposting it. So here's what I'm gonna do. I'm gonna stop. I'm actually gonna stop this. It wasn't working. And I'm going to go back to my parsec. And so this, I have this like reachable at this. I'm gonna do this. Oops. We can rename it to Ryzen. We can name it to desktop GPU or Ryzen or something. It's no longer model relay. Keep model relay working for those that it's set up to work with already. Only the Qwen 3.8 27B that uses model relay should be changed. It's definitely not too slow when it's running on my 4090. Okay. It's doing a good job. It's funny, I'm using the model relay version of Qwen 3.8 27B to make these changes. That's pretty cool. Let's make sure it works. So now I will say model Qwen 3.8, and I want the desktop GPU. It's already set. Let's see if this works. Now I copied this. Yeah. So now we're not going to get that whole problem with the whatever my model relay stuff was in the way. I was just trying to make use of my own software. It turns out my software sucks. So hopefully we won't have the, like, it's not going to keep repeating itself and running into those issues. Hopefully. Note that I am currently running this llama server, but I'll stop it for when you start doing your experiments. One kind of cool thing you can do is NVTop. And so you can see it's loaded up, not that big of a, it's like not taking up all of the VRAM, but it's pegged, maxed out on the amount of GPU it's using, which means this is good. This means you have like a good kernel. This is Vulkan, and it means it's like a good Vulkan kernel. Because if you have a bad kernel, It'll max out somewhere over here, somewhere in the 50%. Like this means we're really taking advantage of everything that we've got. Very important discovery. Total RAM is only 30 gigs? It's a little confused. It is true. It's got like, no, it's not a 32. It's wrong. I'm stopping it because I wanted to know what's going on here. It's starting to think, it's like creating all these things about it. For whatever reason, it searched around and thought that it only was a 32 gigs of RAM thing. But look here. Like, this is, let's see, we're at 36K or 36 gigs of RAM just on Llama server, and that's already more than 32 gigs. This is like, by definition, also look here, out of 111.48. So whatever this queried, it queried wrong. Yeah, 32 gigs of RAM for the host and 96 gigs of RAM dedicated towards the iGPU. Okay, it's doing memory budgeting. This is good. This is like what I wanted it to. Sections. Wow, this is going to be a huge document with 4 appendices. Appendices. And this, it seems like it's getting further now. It's like getting into the code parts instead of just restarting over and over and over again. Ooh. There we go. Wait, is this still... No, it's still thinking. It's writing all the code in its thoughts first. That's fine. This looks reasonable. And it did decide to use only the standard library. It didn't use any HTTPX or anything. Oh, SSE. It's, oh man. What a disaster that we have to deal with all that. Known landmines. Oh yeah, cold start. I wasn't thinking about that. That's not going to be very interesting to watch, is it? I am curious about this. Yeah, there is one. There's a couple of people who have made AWQ Qwen 3.8. 21 gigs? I thought it was going to be 14 or something after compression. Oh, no vision tower. Wow. Good performance, or good output performance. Or good output quality, I should say. It actually turns out to be a little bit harder than I thought it was going to be, just because, yeah, of all the SSE streaming stuff, I wasn't really thinking about that. But as I'm watching it stream, that's clearly something that's going to be a concern. Yeah, that's a good point. It's bringing up the question of what happens if, when we're replaying, like in the replay, for whatever reason, it just returns a really short output. Then we're not really comparing apples to apples, because the amount of tokens output are way less in one of the replayed versions. And I think my answer is going to be, if that happens, it should replay that request. Like, it should discard that request and replay it. It's kind of what I'm thinking. Wow, this model likes to think. It really likes to think, doesn't it? It's like hasn't even started writing code yet. It's thinking about all the code before it writes it. No! What is this? Response was truncated before completion. So that wasn't model relay doing that. Did it hit a limit? Wait, though. No. It's something's messed up. Oh, stop reason equals length. It seems that... Okay, so what's going on here is that we're hitting our length limits on a single response's output. So it's thinking so much that it's running into the limit. And what I'm noticing is that when that happens, it doesn't seem to, when you send the follow-up request, it doesn't seem to include all of that thinking from the previous message and continue it. Let's see something real quick. Pi agent. Let's do models.json. 3.8. Okay. So this is saying max tokens is 32768. 32768. And it does have this preserved thinking. Let me just see what the actual max tokens is. Oh, 131072. Interesting. Oh, but that's a 1M context length. It's not much more than it says about that, but I'll just do 131072. Oh, you know what? Since this one is already via desktop GPU, wait. No, this was wrong already. Well, this was okay. So, okay. This one should be 131072. But this one, because this version through llama.cpp, I've been able to max it because of all the VRAM this thing has. But with the desktop GPU one, I'm just going to have to make this be 100,000. And then I'm going to set the context window here to 100,000. And then this, why is it not stopping? There we go. Okay. Yes, this is probably a session continuation scenario. So that helps because now I know that it's seeing the past response, but also I'm giving it enough token output count that it can get there. But this does give me peace of mind to know it did see the previous tokens, even the thinking that was cut off. I was worried that it wasn't. I was worried that it was just restarting each time. So this probably means that the model relay stuff was fine. It was probably just fine. It's okay. This plan is still being written. You know, once this plan finishes, I realized I didn't tell it explicitly that 8, a quantize of 8 is probably the maximum we want to go. We don't need the BF16. So once it finishes all of this writing, I'll tell it. I'll say we don't need the BF16. We don't even need to try it. Just because the amount of uplift you get in overall quality does not match the amount of performance drop you get. We saw that here. Between here 0 and 0.0005, that's not enough to warrant double the size on disk and all of that. What is this to? Is this like prompt processing? No, it's still outputting. I'm guessing if we just do control, oh no, control O. Oh yeah, see, it's more lines are being created. Yeah, I'll just have it remove this. We don't need that. But this is cool. This is working. This document is exactly what I wanted it to create, and this is all local. I am just like having a hard time with how good this local model is. Like, this is a full document that is like well researched and is correct. That from everything I look at, it's what I wanted to do. It's what I wanted it to output. Usually with local models, it's like, oh no, it's close. I guess it's okay. Let me nudge it in the right direction. Let me really help it out. And then eventually it gets there. But this is like, this is good. And this now has the headroom that it needs to be able to think as long as it wants until it gets all the way up to that 100K token limit. I hope it doesn't take up that much space. Oh, wow. We're already at the 2-hour mark. I can't believe this has taken so long so far. I'll be right back. I got to open some of these windows. Okay, I'm not sure if this will how much this will help with the... Ooh, the breeze is nice. I was getting pretty warm in here. You see it on my forehead? The warmth? Anyway. Well, that's kind of fun how it like fades. I don't know when it... I don't think I ever programmed in a fade, so that must be the default behavior. Pretty cool. Wow, this is still going. This concept of this proxy-based eval system for capturing realistic traffic and then replaying it and getting and using it as a benchmark. I guess it's like a bigger task than I thought. I thought it was going to kind of just like put something together really quickly. I guess it's that I explained the entire thing, including I also explained that I wanted to be a benchmark, and I didn't just explain that I wanted to capture traffic. Like, I think if I had just said, proxy and intercept all this traffic, it wouldn't be taking so long, but it's like really thinking about everything from what I'm reading and seeing. Here, I can actually just start to type my steer right now on this. Now that I've thought about it, it's probably not worth it to even test the full 50 plus gigabyte BF16 version. Let's stick to Q8 as our largest quant that we test. I won't send that yet, but I'm getting it prepared for when, because as soon as this finishes, I wanted to go in and edit that. It's processing 26K for 35 tokens in. Or no, is that what that number means? It might be request number 35. But yeah, okay, so if we were set to 32K as our max before, then we're approaching it. And this is why we were hitting our length limits. Wow, it needs a lot of thought. More than I was expecting, actually. That's like even bigger. Now, we could turn down the thought stuff, but I have read that, and I don't have a good resource, so I'm not going to go and try and look for it, but I've read that with this Qwen model, if you turn down the thinking, it really does a lot worse. I don't know if that's true. Like what I was reading was somebody online was saying that if you turning off thinking and comparing Qwen 3.6 to Qwen 3.8, 3.6 does better. You turn on thinking and Qwen 3.8 just destroys. So it's kind of interesting. It's an interesting concept. The thinking off, the old model might be better. I can hit enter and it's a steer. So it'll wait. You know what's interesting is, will this one hit the output limits? We haven't restarted this one since then. No, it's only so it's going so much slower that we're not hitting those limits as fast. Like it would take us a lot longer to get there. Here we go. Oh, it's gonna write out the entire complete file content. Oh wait, no. It says, let me write out the complete file content, and it just writes out the opening doc string, and it goes, and then the code. I'll write it once in one go. I love that. See, this is what we're missing out by not having the traces from the frontier models, is seeing like their actual thought process. It's kind of fun. So I have to think about what I'm going to capture as my representative traffic. I'm not actually sure. I've got a couple of new projects that I'll probably do it, like start up a little instance of Pi and have it like write a document, like read, explore, write a document, like maybe make a few file changes here and there. That should be enough like agentic captured traffic, especially if it's my real stuff, some of my real like projects and directories. Conversation history, invalid literal. That's smart. Needs to know its Python version. Oh, this is really getting into the whole like we're gonna train a dspark dflash thing. I don't know. Saying, okay, let's drop the training our own for now. It's a nice idea, but it's overly ambitious, takes too long, and let's stick to the off the shelf for now. Oh, you know what? That compaction chain stuff, I think is something I wrote. I think it's something I like kicked off a thread saying like, hey, it'd be cool if like you could go back and see previous compaction stuff. But then I actually stood up and left and walked away from the computer. And let me go while this is going, because we're just like waiting for it. That's a little tangent that I want to go on quick, is that I one of the things that I noticed is that if you look at what happens when Pi compacts, it does a standard compaction. It goes through and it says like, hey, let me like create a summarized version of this entire conversation up till now that could be used for future versions of this conversation. And like there's a prompt that it comes with, and at the output it's like a decent sized chunk of text, right? The brilliant thing that Claude does is it saves at the very end of that summarized version of text, it saves a link to the entire previous conversation. on disk. It says if you want to like, I can't remember what the Claude version says, but if you want to like go look at the previous conversation that is represented by this compaction, go look here. And what's so cool is that every once in a while, Claude will do that. Like the compacted version won't be quite good enough. And it says, okay, I need to go back and like read that part of that conversation. And then it's chained. So like if it goes back to that conversation and that conversation has a compaction at the front, it might need to go back and keep hopping up until it gets there. And that's just not something that Pi has by default. So I was trying to add it to Pi where it could go back and look at the previous chain, like the compaction chain. So I started working on that extension, but then I didn't know it actually landed anything. But it looks like it's broken because it's like erroring whenever it tries to call it with no arguments. Oh, it's going to create a fake backend. Might as well, I guess. Appendices, we're in appendices. And we're at token 16K. Says everything's working. Let me go to, let's see what we got. LLM proxy. Okay, done. Please go in and add a new model provider and one model. We will proxy the... It's got to read the models first to figure out what to do. This is pretty cool. I like how Qwen is doing all the stuff that I wanted to do. Like, I haven't had to really go out to a frontier model. It's kind of cool. It's bootstrapping. Like I'm using it to do my little common tasks on my system. Like, hey, swap this out in Pi agent models. Llama capture. Okay. Cool. Oh, I should switch back to desktop. Okay, so I have this LLM proxy now. Oh, we finished writing our file out too. So the plan is even there. Heck yeah. Let's take a look at the plan quick. Exhaustive performance plan. Goals, non-goals, in the shape of the best. Progress 0.91. Okay, so it has to put all this entire thing back in as prefill. It generated so much. It generated 694 lines that now it has to prefill for the next message. It's kind of fun. But dang, that is slow. 27 tokens a second prefill. We need faster prefill. I'm hiccuping. Oh, I didn't want it to actually start the proxy. I was going to do that myself. But okay, if it wants to start it up, fine. Oh, it's hard because it's going to try and... The model did not answer within 120 seconds. Yeah, that would make sense. And let's take a look. Oops. I don't know if it's going to be able to do 2 tasks at the same time. I don't know if my current model is set up for that. 94%. It's taking a while. Just hold off, man. We have to let this one finish. Hold on a minute. Ooh, it's actually kind of chilly now that I've got this, this breeze coming through. Actually, that would be kind of a fun thing to do. So once I get this proxy working, I'm going to have it look at the compaction chain stuff that I originally built that it like seems unfinished, and I'm going to have it take a look at that and finish it up and get it working better. And that way, it's kind of like something I would really do. We can capture that. That means it's actually doing real work, having it write files and stuff. Wow, this prefill is just so slow. Oh, look at this. It completely cache missed. It's completely cache missed because for whatever reason, no, but it's filling in many tokens. Oh yeah, well, I guess we talked about this. This plan is probably like what, 15,000 tokens, or actually we can see. it was 17,000 tokens. And right now we've generated, or we've pre-filled 10,000. We have to get all the way up to 17,000 before this gets to 100. But the reason why it went from 91 to 95 is because in the scheme of the entirety of, in the scheme of the entirety of the context window, that 17K tokens is still not, it's only 91% to 100. It's still only 9%, I think. Not 100% sure. But yeah, we just have to wait because I don't want this to try and compete and like run a proxy and stuff and do all that yet while this is still prompt processing. Like what if that request comes in and kills this cache and then we have to cache all the way back from the start? Would suck. Would really suck. You know, I was pretty happy with this idea of like we quantize this and we only have 100K tokens, but this model or this version of this, which was using that quantized cache, it was doing okay. One thing I would be curious about is trying different quantization levels and things like that and seeing how it affects the number of thinking tokens. Because one of the things that I've read before is that sometimes when you quantize a model more, it ends up causing it to think more, which is kind of cool. Cool to think about. Gotta just wait. This is why before I was trying to do like news articles and news items, this downtime that tends to happen. And it was like I would have these news articles prepared and go in and like swap over to the news articles and talk about those. But then when I was trying to edit it later, the news articles were just like scattered throughout and hard to figure out and it broke the flow. Maybe I need to go back to that though. Just because this downtime, there's nothing to do and nothing to talk about. In fact, it's even like waiting behind this. 24 tokens a second. That seems to be the limit we're hitting right now. That seems to be where we're plateauing. 1% left. You know what? What I'm realizing is I can actually just use my desktop to capture the traffic. Oh, auto-compacting. Crap. Well, prompt processing is not too crazy. It's going fast. That's what I always worry about compaction is the prompt processing can take a lot of time on that. Okay. Looks like we finished our prefill and now we're serving again. We better hope that cache never dies. Because can you imagine having to wait all the way? So we just waited from 91 to 1 and it took 750 seconds. Multiply that by 10 or more, 11, and that's how much it would take to just pre-fill the entire request up till there. That's not going to be something you want to wait for. So it does make me just think that in general, these local models, one of the things they'll be good for is once agentic coding gets good enough that you're not sitting there and overseeing each individual task. You're setting a goal or you're setting a target or you're set like what I'm going to do here where I set like an optimization target and kind of leave the computer and go away. And like I think like having it continue, auto compact when it needs to, pick up from there and go forward, like continuing forward autonomously while you're kind of like not attending to it. I think that's where these starts to get interesting again, unless we can get prefill better. But with prefill the way it is right now, with how much you have to wait, you either just have to like lean on the tricks that we've got, like these prefix caching stuff, and really make sure your prefix cache never dies, or I don't know, just do what I said, where it's like you're setting high level direction and it's agentically figuring it all out. No, you don't need to support different options. Just make sure it's added to the Pi config and I'll start either 2 proxies or just stop and restart it as I switch between. Yep, it's telling me, okay, then you're probably going to need to pick two different ports, which is fine. That's something. Good thought. Good point. Great, actually. It's like I didn't even have to think of the nuances. Qwen's figuring it all out. Oh, it started both proxies too. So it did this thing where it started up the proxies, and I just wanted to save that as a script so that I don't have to. And like no hup, it's not great. I should probably use screen or tmux or something like that. But whatever. This is just for now. This is doesn't matter. Start proxies.sh. Perfect. Wow, it's even like saving PIDs, checking ports. It's like being good about it. Thinking about edge cases, making it executable for me. Nice. Okay, let's try it. Let's actually try it. Also, write a script to run the benchmark, please. Yeah, because it was creating one where like you pass in a specific capture, but like a specific capture, we might like have multiple sessions. We might do whatever, or we might like want to have each capture be its own. Like we might want to have each capture be its own like project. So one of them would be VLLM, and one would be working on the extension, and another like each one could be its own project, and then you'd want to run on like the cluster of all of them. And I'm also going to say, by the way, my main use case is going to be capturing against desktop and then benchmarking local. Because I think it was like trying to tie them together so you benchmark the same system. We'll see how this works. Oh, it's making a lot of edits. This is like after I said I wanted these edits, it's making a 20 or 33 point plan. It's really planning out every edit. That's cool. I just wanted to go faster, but it's cool. Also, can we make those captures in this dir? We're not. Oh, never mind. They're already there. Edit 8. It's going to do. Is it really going to do 33 plannings of edits? Okay, so closing this, we're going to do, first of all, let's do start proxies. I think it started, but let's see. What happens if I do start proxies again? Oh no. Let's do a stop proxies script as well. Okay. Okay. So I've started the proxies. I'm going to do Pi model capture desktop. Please look at my Pi extensions and find the compaction chain one. Okay, so this is running through the proxy theoretically. Captures desktop. Yeah. Cool. Wait, I want to clear this first though. I want to start over. I want to clear these out. Move to trash. Move to trash. We're starting over. Stop proxies. Start proxies. Does it create? Okay. So it creates these from scratch, starting from nothing. We're going to do Pi. Oops, crap. I wish history persisted. Oh, also, did I just... So we can watch as this does start to get stuff. That's perfect. Oh, it's having a harder time this time. It's like finding... I had this duet concept for a while. It found that. But the previous time it found stuff easier. Wait, what is this doing right now? grep v node modules? That's not what I want. This is just like still chugging on my one edit. My one edit request is like, I didn't expect that was going to be the thing. But see, this is why we need to optimize the performance of this one. And I continue to be impressed with the quantized KV cache version of this. It seems to be working okay. I did find a paper that was, I was looking at quantized K versus quantized V. I had read somewhere that there was like a difference between that. And yeah, basically they were finding that keys matter more than quantize what counts. More for keys, less for values. They tried like doubling the key and doubling the value, and they found that key mattered more. So if you're going to quantize, according to this paper and according to this as well, I think this is a separate lineage, but they also found that k higher than v was better. So if I ever do want to quantize differently, I would choose k with 8. I would leave k at 8, and then maybe the v goes down to 4 or something less. Okay, come on, this is taking forever. I'm gonna start over. We're starting over. I don't want it to go looking everywhere on my computer. Like I'll give it a hint. Cool, it's going through the proxy. We're capturing it. It looks like messages are being added. And this is still going. Yes, it's realizing that it's failing. That's exactly what I wanted it to do. It's getting confused. Okay, this actually, it turned out not to be a good one. Okay. Well, that's exactly it. I think there's a problem with the extension, not with your tool calling. I'd like you to dig in to both the extension source and Pi source and figure out how or why it's not working properly, and then fix it. This will be a decent session to benchmark against. At the same time, maybe while that's going, let's see if I can do this. I'm going to say, actually, oops. Oh, come on. Copy. Pi. Please take a look at this dir and everything about this project. A nice write-up. Don't just read docs and regurgitate. Really read all the files and come to your own conclusions. So this is just like a directory with some of the video editing code that I've consolidated a little bit using Codex. And I gave it like an agent start here.md, there's a pipeline.md, there's an readme.md, but then there's also a bunch of just Python files. And so this is another, let's see, by the way, it's all getting captured into the same log. That's interesting. That's interesting. Well, that's fine. That's realistic. It's realistic to have multiple requests going at the same time. Maybe killing KV cache or doing something. Over here, it's got multiple things going. I gotta close that window again. Be right back. Oops. Testing 1, 2. Interesting. I thought I muted it, but maybe I didn't. So where are we at here now? Okay, so this is doing what I asked. It's creating this like summary. This is, I don't know what the heck this is doing. I'm going to interrupt it. I'm going to say that operation was taking forever. Please do something else. Okay. So there's that. I'll just say like, please write a little quick readme, or the distinguishing trait is epistemic discipline. Interesting. Prompt processing. Oh my gosh, this is still planning its edits. We really do need to optimize it on this system. It was saying Q8. I hope it didn't interpret me saying Q8 being the lowest to mean FP8's not acceptable, because FP8 is fine. If we can serve FP8 on this, then that's fine. Oh, we're back into prompt processing again. Not here. Not processing here. 97%. Just capturing traffic. Like, this is another thing where I'm saying, hey, just like look at run benchmark, make it really nice, show lots of continuous like I want it to like show a progress bar or something. And this is also just more capture for the benchmark that we're creating here. Although now we're really log jamming. Too queued. Yeah, it's always too queued now because I got this one, and this one all working on captured traffic. This will be a good benchmark, I think. Very interesting. It's like running unit tests. Okay. All I did was tell it to write a little summary. Oh, it's like putting the summary in the README, putting it in the source manifest. Oh, it wrote the summary already. Okay. It's all reasonable. Yes, I was going to say I didn't want it to actually go commit, and it's not going to. I'll mention the pending changes and leave the commit decision to the user. Perfect. Because I don't want it to commit. This is just a test. And this is fixing my compaction thing still. And this is like very slowly reading the run benchmark script. It's probably going to have to read the code too. We shall see. But thank goodness for the prompt processing speed on this 4090. Like with all of this context switching, that's going to be tough for a local model. And look, now we've got one that's close to the 100K context limit. So that's cool. Testing, yeah. Now I understand the enum mechanics. Okay. The user indeed did not ask for commit. Hopefully it does not commit. It seems like it really wants to. And how's this doing? Man, it hasn't even gotten to my steer. For some reason I'm not comfortable today. This chair or whatever, the way it's set up, the way I feel like I've just got like, I don't know. I feel like I need to like crack my back, like, when someone lifts you up and it goes, I feel like that's what I need. Or if I go to the gym, sometimes I just hang and like let my back like go a little bit loose, and you just let it out. Just hang from something. I feel like that's what I need. Okay, the VideoForge thing seems to be mostly done. Oh, we're getting an auto compact. That will be another great thing for the transcript. That's perfect. That's great. This thing is still working. I think now, once we have auto compact finish, once this thing finishes working, whatever it decides, like I don't really care about the results, frankly. And then once this finishes, it's like nicer readout. I think once those three things are done, we're ready to go. And then hopefully this should be done by then. This has been quite a slow ordeal here. What's here? Let's check it out. Oh, it's still generating. It's output. So what I'm guessing is it's generating this edit, a big file edit right now. Just a big edit diff. Compaction done. Let's see what it looks like when it's... This is what Qwen 3.8 27B compaction looks like. Compacted from 89K tokens. Original request. Early progress. Blah, blah, blah. Mapped, read, verified, formed. Context for suffix. The assistant had completed broad exploration and verification and was positioned to write the final project write-up. But it did write it. Key facts. Oh, I guess like the last message comes back in again. So that's the suffix. It might be fun to like on stream someday create a compaction model, like a compact, really fast compaction model. And like maybe some of it's distilled from K3, maybe some of it's distilled from Qwen, and then like we put together an RL environment and hill climb on like VR CLI. Verifiable rewards via completion likelihood improvement. It's such a cool idea. Like it would be cool to do a compaction training run based on that. Okay, so this one's kind of done. This one, I hope we're getting close. I just asked it to fix the bugs. What did I say? Dig in and figure out how or why, then fix it. It seems like it's figured it out. It was like some typing problem. And like type passing problem. And then this one, I just told it to like show lots of nice progress. Oh, that's going to be cool. This is neat. It's like imagining how it's going to look. This is pretty cool. Like that, if it looked like that, I'd be happy. An ETA even. Time to first token. This is cool. Gosh, this model is like impressive. And remember, this is still the quantized KV cache version. We haven't really like spent as, this is the one that's not quantized. Did my steers haven't even, oh no, I don't even care anymore about that one. Okay, the way, that's interesting. With Claude Code and with Codex, when you like put 2 or 3 messages as you're steering, as soon as it gets a chance to steer, it chunks all those messages in. But it looks like what this does, Pi does by default, which I'm just a little bit less of a user of Pi. Here's what I think. Like Pi is actually really great as an SDK, as like an API. It's a programmable agent harness and an agent framework, and I freaking love it for that. But like actually using Pi like I'm doing right now is something I do a little bit less. When I'm actually using agents, oftentimes I'm using Claude Code or Codex, and then I program Pi or I script Pi into doing what I want. But that's another reason why we might want to use OMP. Try it out. See how it looks. But yeah, so it looks like what Pi does here is when you do multiple messages and it's for steering, it seems like it chunks one out at a time and it lets that complete. So what happened was I typed something as a steer, and then I typed another steer and hit enter for like follow up, like, oh, this is why. It's because I want to make sure you keep that option open if possible to run on this hardware. But I don't care anymore. But last time I did Alt Up to edit this. Here, let's just do it. Alt Up. Wait. I just get rid of that. It's weird because on my keyboard, it's actually Option Up, not Alt Up. I've got a Keychron keyboard. See how this is doing. Generating fast. Oh, this is still going. It makes sense. This one, it needed to dig in or something and figure it out first. It will be kind of nice if if after compaction, the sessions have access to like the previous chain of them. Like it is going to be a cool thing. I like this extension concept. And it's proven by Claude Code. It's proven that it works. Or at least it's proven that it can work. I don't know if it will work properly with Qwen. Like there's a possibility that Qwen sees that in its compaction, and it goes and it reads that, and it reads so much that it needs it needs compaction again, and it gets itself in a loop. Like if it's not smart enough, if the model has poor behavior, that's the kind of stuff you'll see. Did I set parallel to 1? Yes, I set max concurrent predictions to 1. I don't know if I needed to do that. I think I might like play around with turning that. Well, so yeah, I'll play around with turning that off because I think it could have been servicing this and this at the same time, but it just didn't because it just happens to be serving this one. Now, Yeah, there are some times when serving two at the same time would make it slower. You're just going to steal from it. Like, for example, on this machine, if I have two running at the same time, for the most part, it's not getting any performance benefits. But with that one, because it still has, it's all that paging in and out of the memory. Memory is your bandwidth. That memory bandwidth is your cap. Whereas with the 4090, it's quantized, it's messed up, it's all put on the same thing. But as long as you can fit both like both subcontext windows on the same tape, um, you can actually get more than just like you don't have your performance. You do better than half. And so then you can like pack more and more things on there, maybe like four for this one in 100,000 context window. If it got four things that are like 20,000 K context window, that might be the thing that like maximizes your throughput, because you're every time you add that new context window, it doesn't have your performance. And then if you do that four times, it means that like your overall, each individual one might be going slower, but your overall throughput goes up. It can. That's like something you need to measure. And it depends on the workload and all that. Both backends are up and running. Error terminated. That's new. It probably ran out of time. Kind of my guess. Bench live. This is still generating that edit. It's a massive edit it's generating. It's stuck. I've never seen that before. It's like not progressing. And it's in inference time. Oh, it rewrote run benchmark. First it ran this, it had to create this bench live and then run benchmark. I'll close this just so I'm not like dealing with it anymore. My laptop is at 97 degrees. This extension turned out to be a harder deal than I thought. I think it's taking it very seriously, and it's like trying to get it really right in terms of like dealing with all the edge cases and stuff. I mean, that's good for training data. It's a longer and longer transcript and trajectory. It looks like we're really close. It's looking at the like configuration at this point, and then I'll write the fix, it says. Oh hey, we got our edit, our giant edit, which was almost 10,000 tokens of edit comments. We're actually at 71% of 262K tokens. So this like context window that we're dealing with here is no joke at this point. For a local unified flash or unified memory model. Now, because this generated 10K tokens, we're gonna have to do that thing again where if you scroll up, like we're gonna have 10K tokens of progress to ingest. Yeah, something like that. So we'll wait. We'll wait while that goes. But thankfully, I think we're done. Like, we'll check that this is, but I think it's done. No, I didn't say. I'll say, what if I want to run a benchmark against desktop? So this is done, hopefully. And then this is, we'll see. I thought this would be a quicker deal, but it's like really taking it seriously and getting it right. I will enjoy having this extension once it's done. So it's kind of cool. Was not expecting this to be like a real, I thought it was going to be just a quick like capture for like this was like when I did the VideoForge summary thing. I closed the tab so I can't show, but I thought it was going to be a quick little deal like that. But this is like, it's like, okay, I'm on a mission. I got to fix this extension. I got to think about all the edge cases. I'm going to track down all the problems with the typing, and I'm going to make it work. It doesn't, I'll just say, it doesn't feel like I'm interacting with a local model right now. It feels like probably like I'm dealing with like a Sonnet 5 or something. That's what it kind of feels like, other than just being slow. Run benchmark desktop. Okay. Final review of the finished file. We're getting there. Oops, I got it delivered. I'll be right back. see where we are. Okay, this thing, the compaction chain. Let's see, actually, I'm curious. Oh, okay, so this is done. The thing that's still left is these edits to this dang thing. The plan. Okay, well, at least we just got done on progress. So hopefully it's just gonna, I think what this will do is just like summarize and say, I'm done. We did this. We'll see what it does. But I think that's what it's going to do. This one, I'm ready to run the benchmark real quick and just like see. This one over here, why it wasn't working. Bug 1, the tool could never be called. You were right, it wasn't my calling. Pi bundles typebox 137 treats any non-array object as a TypeScript enum record. Okay, so it was a typing issue like I thought. Bug 2, links were never finalized. Every stored link stuck pending. Links? Oh, the link from compaction to the previous compaction to the previous, like, or to the file or whatever. Okay. Latent, the read path would have crashed. That subpath isn't the package's exports map. Oh, okay. So it was like a JavaScript pathing issue. So the fix is in. So if I reload, did that work? Let's see. Processing prompt. Come on. Hopefully the compaction chain worked, and it won't have any links to previous compactions, but just calling the compaction chain should not error anymore, is my understanding. 86%. No. Oh no. Yes, what if this isn't your bug? There we go. Okay. This is, it had to overcome its own issues. So, I'll run compaction real quick, and then I'll try it. Just to make sure. And while this is finishing. This is still finishing. Remaining issues. Okay. Yeah, if you... I was exactly what I was going to do. Run compact. Let's see. What I don't love is this is all being captured into just one giant JSON-L. I wish these 3 different Pi sessions that I had were being recorded into different files, different conversation files or whatever, because it's like tying, but I guess it's a realistic capture. This is a real Python, it's like a real Python capture of what really I was sending over to the LLM. So theoretically, like, actually this is probably better. There's technically more information here than there would be if I split it out. Because if you split it out, I guess, like, as long as your precision is high enough in your timestamps, you could always combine them. But as of right now, this is showing the literal sequencing, even without looking at timestamps. So that's like, there's something kind of interesting piece there. Compacting context. Let's go. Hey, okay, done. Qwen 3.8 serve plan is the single self-contained doc. Here's what I'm going to say real quick. Like, I hope this doesn't take too long. Git init, git add, git commit. Please be concise. This should just take a few. Yeah, just be concise. Okay, compaction finished. Wait, let's go back to this. Wait, whatever. Okay. Did it work? Check it out. Typo. Embarrassing typo last minute. Check it O2. Ah, no. Okay. Hey. Worked. Cool. Okay. That's good for now. I'm getting out of that. I'm getting out of this. So I think this is what I'm going to do, because my local is, I have to turn off the local inference, and the local isn't going to be basically working well, or it can't be working at all. I'm going to switch this. I'm going to try and keep this all Qwen 3.8 27B. So I'm going to point this. I'll start a new process. And I'll point this at the desktop one with the 100K limit and all that other stuff. But now it will have this compaction thing. So if it needs to, it can go back, like if whatever. And then, okay, perfect. And then this local server will be doing all of the the trials and trying other things. So I'm going to close this out. Actually, before I do any of that, let's see how the benchmark runs. This benchmark is going to take too long, I think. Ooh, that might be something we need to do first, is like find a way to, whoa. We might need to find a way to make this fast. Oh, that's weird. That's cool. Okay, I am going to resume this session quick though. I'm going to stop this. When it's running the benchmark, it seems to mostly good, but there's some slightly strange behavior when it prints something out to the terminal, then afterwards wants to render its progress bar. It seems to move all of the contents up one line at a time until the progress bar is sitting at the top of the terminal. Then when a new thing prints out, milestone whatever, it pushes the progress bar down for a bit, then the progress bar goes up one line at a time again, and this repeats. I hope understand this isn't the best explanation, but if you have trouble figuring it out, please ask or something. So there was that little bit of a weird like benchmark weirdness. While that's going, I'm going to already pre-plan out what my next message is going to be. Is that also I'd like a way of no. So here's the thing. It's like it's going to take, that was going to take 8 minutes at least. It was saying 12 minutes and 39 seconds. One thing I'm worried about is whether this benchmark will take too much time. In just an early preliminary test, it was going to take up to 12, 13 minutes, and I have a feeling it would have been longer than that. On some of the systems we'll be benchmarking local, for example, this will take even longer, maybe by multiples of 3, 5x, to reduce the wall clock time, yet ensure the distribution still matches our real world usage and isn't synthetically different. I'm thinking if we sample chunks of adjacent requests but skip a bunch of the in between, could this be a command line argument for the benchmark? Oh, hey, we got a first message. I missed it earlier. What am I working on tonight? I'm working on basically Qwen 3.8 27B. Trying to learn about it. I'm trying to set up I set up a capture. Oh, you just sent it. Why is it? Oh, hey, it's showing up on screen too. It's a good test of my like on-screen stuff. Yeah, so I'm trying to optimize my system to be the fastest it can be at running Qwen 3.8 27B. And so that involved first, like, instead of just like setting it up and benchmarking it on some trivial benchmark, at first I captured a bunch of like agentic traffic in this JSON-L format, and I'm going to replay that traffic as a benchmark. And then I'm going to use that to be to like try and make it run fast. Yeah, I'm running it locally. I've got two machines. I've got one which is here, which is the this like I pulled it up earlier, but I'll pull it up again. It's this where am I? It's the Evo X2, GMK Tech Evo X2. This thing right here. That's the thing I'm running on locally here, but it's the 128 gigabytes of RAM version. But then I've also got this other server over here with a 4090 with 24 gigs of VRAM. And so this is like, I have to do all kinds of weird quantization to get it running here, but it runs fast. But then when I run on this one, I don't have to do all that quantization, but it's running slow as heck. So, and like, yeah, I was saying earlier that like, this is super expensive now, but I got it back when it was like, it was like a third of the price. I just really lucked out on a good deal. And then the 4090, I was like, it was a splurge, but I was like into gaming back then. Also, I was doing VR development back then, so it made sense for work to do all that stuff. Yeah, 4090 with 24. But so the settings that I've found so far for that to work the best are setting it to 100,000 context window, setting MTP to 2, draft tokens to 2, and then quantizing both the K and the V of the KV cache to 8. I haven't tried any other stuff. Like, I think it's possible that like I could quantize the V part more and then maybe bump up the context window a bit more. Or there's other stuff where potentially like I could get more context out of it, but so far this is what I've found is the best. Okay, so what was I? Could this be a to sample? So what I did here is I captured all this traffic, and I'm replaying it as a benchmark, but it's like going to take too long for each iteration of the benchmark to replay all the traffic. So, but I want it to be representative. I want the traffic to like this to be a representative benchmark. So I'm going to do some sort of like sampling in between where like I sample chunks of it. We'll see what it says. And improve the wall clock time of each benchmark. Right. Oh, this is still going. I wasn't even really noticing, but that's going to be a steer, I guess. Good catch, and that description actually points at a specific bug. Interesting. So I think we're done with the plan. The planning session, so I can close this out. This is the one that's running locally. So really now all I've got is the desktop one with the 4090. Yeah, I'm running Qwen 3.8 27B locally. Yeah, okay. It's gonna resolve my yeah, it's a big open weight model. It's not terabytes to download. It's 50. If you download the full thing, I was looking at it earlier. The full thing is, whoa, why does it look like that now? Why does it look like that? Did they change? Oh, here we go. So it's like, if you add all of these files up together, we found out that it is, what did it say? What did we find? 53, was it this one? No, anyway, we found it's like 53 gigs or something. But then if you download the quantized versions of it, which, let's find a quant. Let's just look at the unsloth quants. If you download the quantized versions of it, they're a lot less. So for example, like the 4Q, this is the one I'm running, 16 gigs. So we're not talking a terabyte, just 16 gigs. And that's why, like, because it's only 16, oh crap, I didn't want to download it. Because it's only 16, that's why it's able to fit on a 4090. Like a 4090 can, like, it's at 17.74 gigs with all the, like, features loaded up. And then the rest of my VRAM on the card is saved for all the KV cache, the context length stuff. It's doing a lot of thinking. Yeah, you should try it. I tried last week. I was trying out Meta's Glimmer 30B. Muse Glimmer 30B. I was trying this out, and it fits a lot more easily onto that 24 gigabyte card, and it's a pretty good model. And if you look at the benchmarks on it, it's like a pretty good model. Especially, it's funny, they compare it to the Qwen 3.6, and I think they got it out there just before 3.8 landed because they wanted to have this like nice comparison here where they beat it sometimes. But just the qualitative difference between running this Glimmer 30B last week and trying out the new Qwen 3.8, it's kind of like a night and day experience. Like when I use Glimmer, like I asked it to create a document at one point, and it created like a 200 line document, which was like pretty good. Like that's a pretty good size. Like it was a decent document. It was fine. But then I tried here earlier today. I just had it create a document, and it like did so much research. It found the surrounding stuff that mattered. It incorporated web searches into it, and then it created like a 600 to 800 line document, which is actually really good. It's this document right here, this plan. Like if you look at this plan here, I'll open it up in a nicer way. Like this is a really high quality document, all generated locally from the 27B. And it's like, it's really well organized. It's listing out all the different steps of the things it's going to do. Like this is actually the plan I've got to optimize the serving of the model on my own system. So I'm going to try and run it down. Like I'm going to point a model at this plan. Like this is a pretty good document. I haven't read it all, of course. There might be bugs or errors, but it did a lot of work. Okay, let's see how this is. This is still going. Your instinct about the adjacent chunks is the right one. Well, it's very sycophantic. Sycophantic. Telling me how great I am. Oh, how does it do web searches? I have a plugin installed. I have this thing called Pi Web Access. I don't have too many extensions, as you see. Like I've got a goal extension, I've got a Pi Web Access extension, and I've got this little one I created this stream called compaction-chain, which just means that like it stores a quick little pointer to the previous compaction, so that if your model wants to, it could go like read the previous transcript. And not rely 100% on this is using Pi, by the way. But yeah, Pi Web Access. This is the plugin that I use, and then it's got it's got support for all these different providers. I think by default Exa is free and comes with it, but I don't really trust the free providers so much. And I do think Exa sounds cool. I need to just play around with it more. But I have a Brave key already. I have it already set up, so I just put this in there, and then it just gives the LLM an extra tool called web search. Actually, it's got a bunch of tools, but I think I filter it down to just web search. Here, let's see what tool it gives. Web search, source check, fetch content's another big one, and get search content. I don't really know what web search and get searched. I don't know. Maybe web search returns like IDs that you get, like that you pass back into get search content. I don't know. It works. It seems to work okay. See how we're doing here. Here we go. Applying the render fix. This thing is rendering away. Yeah, Brave is pretty good. I use it a lot. I use that browser a lot, and I don't know. I've gone back and forth between like whether I think it's a good idea or not, but I like it. I like it. Come on, get your edits right. Hopefully this finishes soon so that we can just do the benchmark. The benchmark is like, it was cool to see it go when I just did it earlier, but we just can't run the full benchmark. It was going to take too long. Oh man, I actually was going to switch this away from this is all still being captured. This is all being put into the benchmark. Like fixing the benchmark is being put into the benchmark. Whoops. Oh well, I guess the benchmark is getting more and more representative of what I do. Like this is me working. Okay. Patched bench live, it has to patch LLM proxy, and then I think there's one more file which will be the run benchmark.sh. I think it'll have to do that too. If it does those three, it should be done. I don't know why sometimes this like stops, it like pauses for long periods of time, and then it generates a bunch of tokens. Whereas most of the time, yeah, like that was odd. It generated a bunch of tokens right there. I guess what must be going on is if this calls it in non-streaming mode. Like when it's doing streaming, it increments, but when it's doing whole request response, it doesn't. I think that's how it's going. Oh, and I think we found out that I guess this is the turn ID or the request index. Earlier, I was thinking maybe this was the amount of tokens, but it doesn't seem true. Okay, all three files. It patched the. Interesting. It used Python. It wrote an inline Python script to edit this bash script file. Yo, dog, I heard you like Python. Or, yo, dog, I heard you liked bash. Oh, auto compacting. Well, we're going to see if my. Although I don't think this has the updated extension. Oh, there's a lot of hurry up and wait here today. Yeah, LM Studio. Yeah, this is LM Studio that I'm using. It's a little like Ollama. I'm not the biggest fan of Ollama because some of their defaults and some of the things they try and make a really user-friendly product, which means that they want to keep configuration to a minimum, which is great, right? Like it's always better when things just work, when you boot them up and they just work. But some of the stuff that they do hides from you and makes it difficult to make things work like in proper ways. Like for example, they have this weird context windowing stuff where it's true that most like KV cache is a problem. That's why I had to quantize this one and I had to do all that stuff. But rather than just having like a giant database of all the different cards and situations and like that would be the better way to do it probably, they try and build algorithms that automatically sort of adapt to your environment. And it means that like for example, as you're typing and or as your agent is working, like stuff is falling off of the back of the context window of Ollama. Whereas with LM Studio, you're going to get a little bit less of that. It exposes more stuff to you for tweaking, but like you need to tweak those things. Otherwise it won't always work properly. And specifically like things like the context window. Like, yeah, it's not, they're not going to be able to just crank that up all the way to the max, maybe. But like you dialing it in is kind of the way to go for now. Maybe someday, maybe an LLM someday will self-configure. Okay, compaction done. And we got one more thing here. Okay, so chunks 2, chunk 3. What does that mean? Chunks 2. What is chunk? I get chunks 2, but I don't get chunk 3. Okay, against the mock server, might as well. I'm actually kind of glad it did the mock model. I was mad at it before. Oh. I don't know where the mock model is. Oops. I don't know where the mock model is. We gotta wait. Okay, fine. It's really getting into the like conversation specific stuff. I don't care that much. I might just stop this. Unless it's onto something. Let's see. Found a bug. Better it than me, I guess. Tokens go burr. Yep, tokens go burr. Although they could go burr faster as far as I'm concerned. Full terminal emulator test. Okay. Overkill, but cool. It loves writing inline Python. Yeah, the Nemotron models are great. It's just I haven't found one that I can run in this type of situation, this type of setting where it works well enough that I can kind of like treat it like a sonnet model or something like that. But this, I'm kind of getting there. But yeah, Nemotron models are good. And the nice thing about Nemotron models is they give you almost all of their training recipe, like the entire training recipe, like the data that they create, the reward models that they use. They give away a lot of the reward models. They make it so that if you want to, you can retrain the entire thing. There's a few, I think there's like bits of proprietary data that they don't provide, but it's like far and away the lesser of the, like for the most part, they're giving you everything. And a lot of the stuff that they're doing is frontier level. Like they're using MOPD. I think it was the newest paper. Yeah, like they're doing what like all the frontier labs are doing, where they train all these teacher models and then use on-policy distillation to merge it back in, and then train a bunch of teacher models on that, use on-policy distillation to merge it in. So yeah, the Nemotron models, I've got my eye on them, and it makes sense, honestly, because NVIDIA, like, okay, if NVIDIA was trying to protect their like training infrastructure moat, that would be one thing. Like they wouldn't probably release all of this stuff because it's making it easier and easier to train models. But they are going to make so much more of their money in the future on inference, on just like inference. So the more models they can get out there, the more people training them, the more specialized models where people need to run it on their own clouds. Like it makes a lot of sense for NVIDIA to be the one pushing these open model things. It's funny that it ends up being China, but NVIDIA seems to have the most like financial incentive to be pushing for open models. Yeah, NVIDIA on Open Router. And it's fast too. They're fast models. They have pretty good performance characteristics usually. But it's always better if you can make it local. Come on, this is taking quite a while. Now it's moving the dashboard down a line. Before it was moving the dashboard up a line, now it's moving it down. It's got to be like some tricky thing with like character terminal ANSI escape code thing. I'm glad it's not me debugging it. Yeah, it's some weird ANSI terminal escape BS. It's getting quite excited. It's getting exclamation points in its thoughts. I love all the actually, wait. Okay. So all those pivot tokens. It can't produce the upward movement. Let me just try again. Wait, what was it? Chunk 3? Yeah, it still moves up. It still just travels upwards. It's like, okay, if I just write this code, this moves it up 4 lines. So it's like doing a whiteboard interview problem. Ow! I think I finally get it! Eureka! We are really missing out with not getting these thoughts on the frontier models. Even if they think like a caveman. This is stupid anyway. It's just like a cosmetic thing. It doesn't matter. But I don't know. I want it to look nice. I'll let it generate 4,000 or 5,000 tokens to get it looking nice. Edge cases. This is getting complicated. Oh my gosh. Interesting. Look at these chunks it's coming in. It's coming in very large chunks, meaning the multi-token prediction is working on this thought chunk. These are not coming, you're not seeing it come in 1 token at a time right now. I thought I set it to be a maximum of 2 tokens. So when you set a maximum, when you set max draft tokens of 2, I would not be expecting to see these big chunks coming back like that. I would expect to see maybe 1.5 words come through at a time. But I'm seeing like 5 words at a time. So I'm wondering if maybe this isn't as sticky as possible. Like if it automatically, no, that's odd. Maybe it's a buffering thing where it's like buffering multiple response tokens before sending it back. Okay, you can do this. You can do this, Qwen. What are we at on thought tokens here? 10K. 10K thought tokens. Jeez. Ooh, it's bolding its thoughts now. I almost feel bad making it do all this just for some cosmetic crap. Okay, it's getting into code. That should be a good sign. Wait, but no. Oh, it's just like me. Wait, this is getting tangled. Let me simplify. Hey, I found the root cause. And then I have to say, so what is the CLI option should use to limit the wall clock time, given what's in there now, and a target of a 5-minute wall clock time, and local model running at 15 second. What value should I choose? I'm getting this ready. I'm not going to use it yet. I'm getting it ready. There we go. It's right in the file now. I actually hear the fan on the desktop spinning up in the other room. I hear it spinning up. The GPU fan is cooking. So it rewrote. What did it rewrite? Bench live. It wrote another Python program to do basic file edits. It's so weird how it does that. I'm finding Qwen really likes to write inline Python code. It's good to know. You know what? While this goes, I'm gonna use Codex for this one. Yeah, why chunks and chunk? Yeah. Yeah. Chunks and chunk. Not the most descriptive. It's not self-documenting, that's for sure. Come on, Qwen, you're doing a great job, but better variable naming. Better variable naming. Or I guess CLI option naming. Oh, that's interesting. What did that say? Okay. The threshold is being calculated from the actual terminal row count, but my emulator... Oh, never mind. Okay. Chunks K means how many windows to sample from each... Oh, okay. So total number of chunks. Chunk C, how many consecutive turns? Oh, so per chunk. So this is like number of chunks, and this is chunk size. Take 2 adjacent turns near the beginning, middle, and end. 3, okay. So I will pick chunk... Well, this will help me. Chunk 3 and 3, okay. I feel like chunks 3 is very low. But we'll start with that, and then we'll see what it does. Come on. Ah, I see the flaw now. Oh no, compaction. And I don't think this gets my nice new compaction stuff. Well, it's too late. I was gonna try and reload the extensions, but let's just let this go. Let's let it cook. But I will prepare this to be chunks 3, chunk 3. Actually, I'll do, yeah. Chunk 3, chunks 3. Because I might change chunks more often than chunk. Bad naming, though. Come on, Qwen. Get it together. It's actually starting to get dark outside. When I first started the stream, it was so bright. I was like over brightened. And now in an hour, it'll probably be dark. My goal is to kick off this optimization process. Yeah, I'm in San Francisco. My goal is to kick off this optimization process. And I probably will end the stream when that starts, but I'll continue recording, and then I'll do like a time lapse or something later. I don't know, because it's probably gonna spend hours once we get the benchmark. Once I have this plan file for this optimization. it has to run. And I don't know. I got to just like let it go at that point. I can't really say anything or do anything. And I can't interrupt it too much or else it will skew the results. So I'll probably end stream and like record it. But we've got a ways to go before we get there. Oh, this is still thinking. Oh no, it didn't work. I want to see. Well, no. I would ruin the... Like, this is streaming right now from the box I was going to try and benchmark. But, you know, it'll be interesting because a lot of times what happens is when you get towards the end of the context window, it starts to degrade a little bit. Even though this isn't a full context window, it's only 100K. Oh, this might be where we're starting to see some of the context window quantization stuff come into play. So we'll see if after compaction, if it's getting better. If it's got a little more smarts. What was that? Excellent. Excellent. That's my impression of Qwen. Excellent. I'm glad it's running these tests. It's finding problems, finding fixes. Yeah. The raccoon gif. Hey, hey. Oh, mock. Come on. What is this mock? Where is it? Okay, I have to quick see. Restart mock server. Mock? Oh, it's in temp. I was looking for like, where's this mock LLM thing it created? It's in temp. It should just do a copy quick. Shouldn't take long. But that's cool. It's testing itself. But why is it taking so long? Oh, there we go. Works. Okay. I think it's ready. It keeps just checking itself. Local URL, it's overriding. I think I'm going to try it. I think I'm going to try this. Let's try it. Hey. Hey. It's not traveling upwards. But wait, though. Why is it doing 65 turns? I thought we said to do 3 only. Oh, wait. Crap. I did the thing I said I wasn't going to do. Oh, that's because this is running... It's not really running against the desktop. Here. While that's going against the desktop, potentially, I will run this against local. Once this boots up, it's loaded. Let's just see. Processing prompt. Okay. Not sure what this is taking so long. It must be doing a simulation where the local LLM, like this mock LLM, is like doing time.sleeps or something. But so if I'm correct here, I don't know why this is why this is set to do so many more, because I set chunks to 3. Chunks 3. So it should do 9 requests, not 65. Maybe it just ends early. We'll see. Prompt processing is brutal. Yeah, that makes sense. Okay, so this is the first chunk of 3. 1, 2, 3. And then it's probably going to do like, what is in the middle of 65? I don't know, 31, 32, 33 or something like that. And that's why it's taking longer, is because we jump to the middle. The ones that are in the middle have a bunch of prefix that needs to be prompt processed. So that actually makes sense. Everything's fine. Everything's fine. Everything checks out. All right, let me clean up. So where's this going? We're still prompt processing that second chunk, the first one of the second chunk. Now I do expect that the second and third of that second chunk will be faster because it will have theoretically kept all the prompt prefix caching stuff going on, but we'll see. 81%. And this is good. Okay. So local captures desktop. Interesting. Yeah. So let's try that. We're going to run against my desktop, which is a lot faster. And I'm going to use what is local? No, I want desktop. I'm going to test against the desktop with the captures from the desktop and do 3x4. Should see this go. Yeah. It's going to go a lot faster than this one. But this one is still... Wait, we just hit 100% on this one. So I expect this one will start to go quick. Or we'll see the next one soon. Yep. Okay, and it did. It did exactly what I expected, where it jumped up. I kind of would prefer it didn't show me all 65. It just showed me the filtered version. But it's kind of nice, actually, to see. I wish it would affect the ETA. Oh, this is already going... This is going way fast. And this is the exact same... These are the exact same prompts being sent to both. So that shows the 4090 versus this local. And how fast the prompt processing happened. Okay, so what I'm going to do while this goes is I'm going to say, well, I've got both machines going now. But what I think I'll do... Oh, that was codecs. That was kind of what I was... Actually, let me resume this. I'm just going to use codecs. I'm cheating a little bit. Oh, hey, you got it loaded. Nice. That works. That's cool. Pretty fast download, huh? I mean, it's 16 gigs. It's not small, but it's not huge. Loaded into regular RAM is not great. Gotta load it into VRAM for sure. Model offloading for the win. Please read plan.md. I'm going to say update plan.md to ensure that this is the benchmark that is run each time. Oh, interesting. Interesting. It's repeating. So it did 1, 2, 3, 4. Wait, yeah, chunk 4. It did 1, 2, 3, 4, 31, 2, 3, 4, 6, 2, 3, 6, 4, 5. So that's like, I was expecting this and this, but I wasn't expecting this. Why is it doing it again? Oops. I'm going to ask. Oops. Crap. I can't copy. It keeps changing. I can't copy. Here, I'll screenshot. Oh, repeats 1. I don't even need the screenshot. Repeats 1. I don't know if I want the repeat. Maybe I do want the repeat. It makes sense. You want it to like go through twice. Let's see if... Repeats. I can just say repeats 0. Or I just leave it. I'll just leave it for now. It's not the worst thing in the world to have this thing repeating those. But wait, did it do it again? 13, 14, 15, 16. Let's see what it says. Because that's a little odd to me. Oh, it's like multiple conversations. So it is separating out the conversations. Oh. Yeah, I'm just going to have it limit down to like 1 or 2 of the conversations. Or 2, yeah. Oh, we got a bunch of one-turners. Oh, I bet these are compactions. That's my guess. Yeah, 1 conversation is fine for now. Okay. So, done with this, done with the... I'm going to be done with these. I want to just do 1 time of trying this out with the new... Okay, I'm not going to do local. I'll do desktop. Hopefully it should just follow through 1 thing and then be done. And this I'm closing. So, the one that actually is going to do the work. Let's do Pi. Model to desktop, GPU. And then I'm going to do goal. Read plan.md and proceed to implement, to continue to work down the list until you are extremely confident that you have the best possible, fastest configuration and setup for serving Qwen 3.8 27B using the included benchmark to test to gather real world target to test against the expected target inference distribution, agentic coding, and work. Please continue to iterate on the plan relentlessly until there is a clear and certain winner that you can present with confidence. Okay, what did this say? Oh, this finished. This finished. It went through. It did all. It captured it. This is exactly what we wanted to see in terms of the benchmark, and that took what 1 minute and 53 seconds. It might. Well, so this is the desktop, so it's going to be faster. If we did this, I'm not going to do. Actually, I kind of want to do local real quick just to see how long it takes. And we have a direct comparison. So whereas before that took 1 minute and 53 seconds on the 4090, it should probably take 3 times as long here, is going to be my guess. Maybe more because prompt processing, but we'll see. Let's just see. The ETA is actually, I was wrong before when I was saying, hey, how come it's showing so much on that progress bar when it's skipping all of these things? No, it was being smarter than me. It was taking all of the different skipped things and putting it all into one progress bar. Those first three are pretty fast, but they were going to be. Like the middle ones and the later ones have more context. So this is where we're going to see the slowdown. Huh? This one's going to be fast. Oh, I guess that was 4. Okay, so that's the first chunk of 4. And now comes the second chunk of 4, and I'm expecting this is going to take longer. Yeah, progress is 0.23. We're skipping way ahead in the conversation trajectory. I'm curious how close it's going to get to, like I was in my mind, I was thinking 5 minutes per benchmark run. I am curious how it's going to do against my mental sort of target. It's taking quite a while to do the prompt processing. Might overshoot 5 minutes is my current thinking. Yeah, it's already the ETA is beyond it. But once we get that first one done, the next two, like the chunk the next 3 in that chunk of 4 will go faster. And then it's going to take a long time again on that last chunk of 4 for the first one, and then the next 3 on that last chunk of 4 will go fast. So we really might end up at 5 minutes, but I'm guessing it's going to be something more like 6 or 7 minutes when all is said and done. Let's see where we are in the prompt processing is 61%. It's amazing how prompt processing really does. It's like a linear function of how many tokens you have in the window already, where it's like at the beginning, prompt processing is fast. It's 370 tokens a second, and then it's 308 tokens a second, then 286 tokens a second. And it just keeps getting lower and lower and lower. And earlier, before, we were seeing about, what is it? It was like leveling off at like 24 tokens a second. So it's interesting how there's this like, I don't know, diminishing returns of, or it's like, I don't know, exponential back off on, or asymptote or something on prompt processing. I have to say it's not entirely intuitive to me why prompt processing is faster than inference. It's not entirely intuitive to me. Oh wait, canceled. Is that a timeout? I don't want timeouts. I'm glad I tested. That might have actually caused like weirdness in the results. And yeah, at least the prefix cache picked up from where it was, but that wouldn't have been good. It's 30-second timeout? No way! Fail. I'm cheating and using codecs to do this. Ooh, it keeps failing. 30 seconds is not enough time. It's doing error handling in this. If I accidentally pass less than 0. This isn't like something we're publishing codecs. Okay, so I'm going to stop this and restart it. It's not quite done. Okay. Stop this, restart it. I think it might go faster because there's prefix caching. We'll see. Or not. Interesting. It seems to not be working the same. That's odd. There we go. I wonder why that did that. And that resets the clock a little bit in terms of there won't be another, like we just have to let it run again and see if it, this time when it gets to that second stage, that second chunk, it's just going to sit there and wait. And we have to make sure that it waits long enough. So that just means we have to sit here and wait for probably 184 seconds or more, actually, because this only got to 70. Probably, I don't know, 300 seconds. It kind of makes me want to just start this goal mode though. But let's see. Yeah, I'm still trying to dial in what I do here. Do I know how much VRAM 100K context takes up? It depends on your quantization, if you're quantizing the KV cache. But one way that's good to check and see is when you actually, here, I'll show you, when you load it, when you're like loading this, and if you don't do advanced settings, it doesn't show as much nice stuff. But when you're loading it, do you see how it says 23.52 gigabytes? You can watch as the options that you change affect that. So like if I do full F32, it's going to be 31.94. If I do Q4, it's down to 22.10 or whatever. So when you load it, so 23.52 and then 17.74. What was it? 23 point something? I forget. But so if you do the math and you do subtraction, that's the part that's left over for the KV cache. Glad I could help. It's good to do something while I'm waiting for this prefill to work. Yeah, I'm trying to dial in what I do. Like last couple of streams, what I've had set up is like a bunch of news articles where whenever I'm waiting for something like this to happen, I go and like read one of the news articles and talk about it and comment on it. But then like when I was trying to edit the videos later, it was like terrible. It was like there was all this interspersed stuff and I was trying to figure out where do I even cut and what goes where, and I don't know. And so this time I'm trying to do a thing where I just focus on one thing at once. But now we're 5 hours into the stream and I'm still on this one thing. And whenever it's just sitting there doing something, I'm just sitting here watching it. So I still have to dial in, like, for these streams, how am I going to like pass time? Like, it's just interesting. Like in the old days, you'd just be writing code and the stream would be like digging into the code or zooming in onto one part of it, or like, and there's no stopping. There's just flow state. But now with agents, you sit there, you type one little thing, hit enter, and then you wait, and you're sitting here just waiting. So try to figure it out. I'll figure it out. Or I'll stop streaming. I don't know. This is all new anyway for me. Although I will say, so the reason why I'm doing this streaming stuff like this is because I just want practice in talking about stuff that's cool. And I used to be really good at it. Like back a couple years ago, I used to be so good at, like, I could just get up and talk about, at the time, like Django or Python or Go or any of the things I was into then. And then I feel like I've lost it. Like a couple months ago, I had an opportunity to get up and like give a lightning talk, and I was just like kind of like blanking on giving the talk. So this is good practice for that. And then actually at work the other day, I had to give a quick talk, and I was like kind of recalling some of the stream stuff that I've been doing, and I think it is helping. It's like just practice makes perfect. But yeah. So I don't know, doing it mostly for me, but it's also good to just get this stuff out there too. Yeah, with agents, you got to have 3 or 4 going. You got to have a bunch going. I mean, with this, I'm limited by my inference stuff. Like, I can't have 3 going because it'll make all 3 slower. But it's true though, when you're doing like, especially if like I'm using a little codecs here and there. Like if I did for most of the stream, if I was focusing on codecs, you just have a bunch of them going at the same time. But it's still the same problem of if I ever want to cut and edit the video down, how do you take all 3 of the things? You're tabbing between all 3. You're like dive back in and checking, okay, where's this one at? Oh, I need to give it an update. I need to re-steer it and dive back out and dive back in. It's like, okay, there's another thing. So, but maybe the solution is just to do that, just to like, you know, go back and forth between a bunch of different things and like AI sorts it out later. Maybe I get AI to reclip everything and put it all in an order that makes sense, which I do have a little bit of code to try and do, but it's tough. It's tough. I think that's the trick. I'll probably do that next time. I'll go back to next time having like a list of news articles and videos and stuff. One thing I would like to do someday is do I still haven't watched the Black Hat video where OpenAI people talk about their stuff escaping containment or whatever. I wanted to do like a react video to that, but I've caught so much of the details just from all the articles going around that I don't know if the react video will make any sense anymore. But yeah, like doing that in the middle in between. Hey, we got it. Okay, so it took, it took a lot of time, 413,000 milliseconds, but that intermediate one worked. And I like that this is actually separating out the time to first token to the tokens per second, because it's true. It's like the time to the first token was really long. It took a long time to generate that first one because it had to do all the prefix caching stuff. But like, okay, once it did, how fast was the output? The output was 20 tokens a second. And then the follow-up, because this is like a chunk of adjacent ones, the prefix cache was reused. So this kind of I like this as a nice, reasonably good benchmark in my opinion that I created just now. Pretty cool. But we are well over 5 minutes for this. That sucks. I wanted this to be a 5-minute thing, and this is going to do a repeat, right? So, although if it's going to do a repeat, why is it already 50% done? It should only hit 50% done when it gets to the end of that third chunk. But whatever. I actually feel good enough about this. Like, this is a good enough benchmark to give directionality and not be just a toy benchmark. I hate those toy benchmarks where it puts in like, you know, these problems, these questions that are like 0 and 10 tokens and expects output that's like 500 tokens. It's like, that's just not the way. If you're tuning for that, you'll set a bunch of different parameters than if you tune for this. Like, one of the tuning knobs that I'm curious about what comes out of all this is the multi-token prediction number here. Because I was when Muse Glimmer came out, 30B, I was playing around with this, and it was interesting because depending on the actual stuff that you want to inference, you'll want different values there. So for example, I was finding out that like outputting JSON, if I was prompting for JSON output, I could push that draft token amount way higher. I was pushing it up to 4 or 5, and it was working because when you have these like JSON stuff, there's so many tokens that you just like, once you get to the next like let's say you're doing a JSON object, you get to the end of the object or the end of a string, and you know it's going to be like a comma, you know it's going to be a new line, you know there's going to be a bunch of spaces. Like all that stuff was didn't take much intelligence to figure out that the next sequence of tokens that were coming. And so for the draft model could just chunk out those huge chunks of tokens for the JSON, and only when it got to the actual fields did it need to did like this multi-token prediction stuff start to work worse. But then and same with code. I think for a lot of code stuff. But then there were other things that I was trying, like I was doing generation of stories. I was doing story generation explorations, and like the story generation stuff, as soon as I started pushing the multi-token prediction above 2, like to 3 or 4 or 5, it was making my performance worse because it was doing too much of like generating ahead and then going, oh, actually these didn't fill in properly, I need to do it one by one, and then generating ahead and going back and saying, oh, I need to fill in one by one. And that process was slower than just bumping down, generating less chunks at a time, going down to 2, for example, and then that worked more often, and so you had to go back and backtrack less. And so this is the value that I'm probably the most interested in terms of like tuning within a configuration. I'm also really interested in, like, if we look at the plan. Oh man, this plan is so involved. Speculative decoding methods. So the MTP is the one that I've been using. It's the one that's built in, but we've got dflash and dspark, and there's no dflash yet, but there's a dspark out there. So I'm really curious, like on this machine, I can see many configurations in which dspark would result in a slower process because it's an extra model you have to run. You're doing literally an extra inference pass on the front of the model before you run the model itself. And so is there any configuration that this thing can figure out how to do in which the dspark augmented model is actually faster than just running the MTP natively inside the model? I'm not sure. I'll be super curious. And then even within that, within the dspark, then you get a bunch more sort of like, you can push that up to 16 on draft tokens potentially. So is that right? Should we go all the way to 16, or should we bump that back? Maybe 6, maybe 4, maybe 10, maybe 8. I am going to be just so curious. Also, the other thing is, there is, oh, well, I don't even think we need it anymore, but there is a dflash for Qwen 3.6, right? And Qwen 3.8 is the exact same architecture in every way except for post-training of Qwen 3.6. So could you use a Qwen 3.6 dflash speculator for Qwen 3.8? I bet you could. I don't know how high the accuracy will, like, will you be able to dial it in so that actually benefits you, or will it just fit in the slots? Hey, well, it was great to meet you. Thanks for stopping by. You're my first chatter, basically. It was cool to see my little vibe coded chat overlay work too. But yeah, thanks. It was nice to meet you. Yeah, so I'm going to let this go once more. I'm going to let this one pass of local benchmarking finish. I want to just see this end to end, because last time I let it go, we found a bug that needed to be fixed that would have caused a bunch of problems. So once I see this go end to end once, and it does suck that it's 15 minutes. That's too long. That's too long. I'll probably feed the, actually, before I do that, I'll feed this in one more time to say no repeats, probably, or no. Dang, it's tough. This just needs to be faster. I'm only sampling 3 little things. We just need this to be faster. 95%. 97%. Getting closer. But yeah, like I was saying, once this goes end to end once, I'm going to actually hit enter on this thing, which starts the goal, and is going to just hopefully combinatorially try all of the different combinations of serving profiles that tries to maximize performance on my actual real use cases. We got our first later batch one done, 23. And see, yeah, the next are going to be faster. And then the repeat, should I need it to do the repeat? Should I make it do a repeat? Maybe. Is it going to do the repeat? That's what I want to know at this point. I think it's going to do the repeat. And if it does, I'll stop it. I don't want it to. In fact, oh, hey. Yeah, repeat. Never mind. Yeah, okay. So it already does. So let's see how this goes. This is going to use my desktop GPU in goal mode to read plan and just go for it. We're going to see. And I will turn this off so that we are starting from nothing. Multi-day plan. Cool. Realistically, within this session, I need to run as many cells as I can, record results in the lab tree, generate the leaderboard in report.md, and create servebest.sh. That's cool. Tonight, I want to okay. Shows 12 turns, 2,218 tokens, and 22.84 tokens per second median. Okay, this is the current configuration. Oh, it found UV, good. It's not satisfied until it's read all these files, I guess. It's not content to just use them. It wants to read them before it uses them. I understand that. I feel that way sometimes too, Qwen. I've established a performance baseline. 18 hours. This is cool. It's like putting together its plan. So seems like it's setting everything up now. It's used a lot of its context window to get this far, though. It's going to compact soon and then resume its goal, I'm assuming. Cool. It's downloading the files that it needs. What is this plan 8? What the? Ugh. Whatever. This is kind of what I was trying to avoid with this captured real world traffic. But if it's going to do these two, that's fine as long as it's in addition to. What is the... I really wish it didn't do that synthetic stuff. But whatever. It just created it. It's fine. I just wish it... Lab bench suites. Oh well. Okay, well, I think that's it for the stream today because I can't really do much more. My local is going to be running and my desktop is going to be running and it's going to be optimizing itself and trying a bunch of different things. And I can't really use the system much while that's going or do anything really while that's going. So I'm going to stop the stream now. This was great. This was fun. It was a good 5.5 hours. And I guess next week I can talk about how this worked out and what the best solution was and share that for other people that are potentially using a similar system to me. And then, yeah, I've learned a lot about this stream and how to, what might be good or bad for the stream. I think next stream I will go back to having news in there and I will go back to having more smaller sections rather than one big project. Although this wasn't meant to be one big project anyway. It just kind of turned into that. But there's just so much stuff to do, so much stuff to talk about. It took up the 5-hour window here today. So that just happens sometimes. Oh crap. I'm talking in a tiny little window. I should probably talking head. This is maybe a little bit better of an outro. Yeah, so that was it today. We did a lot of fun stuff, although it was all kind of one project. It ended up being just this one thing that we spent the whole time on. I'm still figuring out how to dial that in and how I'm going to do these streams and format them. But it was cool that we had a chatter today. That was fun. Somebody who was actually talking back and giving feedback about what was going on. And yeah, I'm just going to let this keep going. I'm going to let this experiment continue and learn and try different variations on the various different serving options and combinations and tweaks and seeing which ones work the best on this particular system. And once I know that, once we figure that all out, I'll share next time about what the best one was. And then I might even like write a blog post or some sort of a post somewhere where I can share for other people what the best solution is for this particular GMK tech, or for the 395 plus, the Strix Halo. Would be nice if I could share for everybody who has a Strix Halo, which includes framework desktop people, what the best solution is for serving Qwen 3.8 27B. I have to say my closing thoughts on Qwen 3.8 27B is that this really does feel like the first model that you can just unplug your internet, go offline, and have a reasonable partner to work with. It's not something that I think you can turn like an instruction over to and then have it just go without sort of oversight or anything like that. I don't think it's that quite targeted and agentic yet, but we'll see. That's exactly what I'm doing here. I do have a little bit of helper. I've got a goal helper that is helping keep things on track so that after compaction, it resumes and continues going on. But that's just a small bit of scaffolding. That's a open source thing that anyone could install, anybody with Pi. So I think the real question is just going to be, how far does this get? This is a great experiment to see, because I'm using one version of it to optimize another version of it, and it's just going to go. And however many compaction cycles it takes, and however long it wants to try, and however many experiments it wants to run, it is supposed to keep track of its progress. It's supposed to write down notes. It's supposed to write down running totals and things like that. We'll see if it forgets over time, if it remembers. Now, I remember I do have one slight wrinkle here, which is that I'm not running the full context window. I'm only going to 100K context, and that 100K context does have quantization of 8 bits. So there's some handicap that this is running on. But I think it's fair, because I think this model is really targeted towards those sort of that class of architecture, that class of card, the 24 gigabyte class. I think it might be better on a 48 gigabyte, but it really does also. I don't think they would have released it if it couldn't be quantized and run on a 24 gigabyte card. Now that I say that, I don't know, but I think that is one important consumer, is all the people out there with 3090s, 4090s, 7900 XTXs. All of those cards are floating out there, and also not just in people's computers and in consumer places, but a lot of these GPU rental companies have a bunch of 4090s. They have a bunch of 3090s. They have a bunch of L40s or whatever. So that class of card being a target for Qwen 27B, I think it makes sense to kind of like test it under that circumstance. So if I find out that this just can't keep up, it can't run an experiment, it can't keep on track for very long, I think it's totally fair for that to be an objection, and for me to say, okay, well, then I need to just run it slower, offload the KV cache to memory instead of having it on VRAM, do the full fat KV cache, not just an 8-bit quant, and push it out all the way to the full size of the context window. And then at that point, it even makes sense to say, okay, is a 4-bit quant too small? Maybe I need to be running a Q6 or something like that in order to get, and maybe with those changes, it can stay on task and it can stay on target. But I have to say, from what I'm seeing right now, I'm looking at this go. Like, I'm here. Let's switch over real quick. I'm watching this go, and it's just it's at 81.9% of its context window. But so far, it's just been absolutely going down the list, doing everything that I asked it to do. And so, the question is just going to be, where does this end? Where does this end up? And I just want to say, this does feel like a game changer in the sense that there have been local models that you could try before. I feel like local models that you could try before were like Qwen 3.7 class, where you can, a Sonnet 3.7 class, where I remember with Sonnet 3.7 and Claude Code, you could get all of your code done with just that. Like I actually was at the time writing all of my code with Qwen 3.7, or sorry, with Sonnet 3.7 and Claude Code at the time. But what you had to do was be very particular. You used to have to walk it through your steps. You used to have to say, load this file, now load that file, now read this, now consider that. Okay, now write a plan, follow the plan. Now, and you know, like you had to walk it through every single step until you got to the very end. And then it was kind of like, okay, now write that code. And even then you were looking at the code, you were giving it feedback saying, hey, that didn't work out very well. You know, change your implementation strategy, or you missed this part, go read that file. Like it was a lot of iterative back and forth with a human in the loop. And I think as we've gone to the better models on the commercial side and on the frontier side, you just have to do a whole lot less steering, and you have to be in the loop a lot less, so that your original task can just be some high level goal or high level task, and it can figure out all those details for you. I feel that the local models up until now have been like Sonnet 3.7, where you had to that you could totally do all of your work with, you know, Laguna Poolside, or you could do all of your work with Muse Glimmer. Even I think you could. I think if you had just Muse Glimmer and you're a developer and you've got like Pi coding agent, you could do all of your work with just Muse Glimmer. But you have to guide it, you have to watch over it, you have to put in loops or some sort of adversarial improvement. Like you have to be doing code review. You have to do all of that manually and do that work. This is the first time a local model feels like it's skipping ahead and skipping to that next level, where you're giving it a high level goal, and it's only when it just makes a mistake here and there you guide it. And those mistakes seem like they're fewer and far between compared to in the past. So if we can figure out ways to serve this faster, if we can figure out ways to solve some of that some of the prefill issues that I've been seeing in this stream, if we can find ways to solve all of those things, then the intelligence level of this model feels like it's getting quite close to what is needed for local development. So yeah, I think it's exciting. So far, like, I only cheated once or twice. There were only 2 times when I called out to Codex to go fix something, and that was just because both of my other computers were like under load. Both of the local one and my 4090 were both like cranking on something, and I wanted to get something else just done in the meantime. So I think that's like, actually, if you evaluate that and you think about it, I think that might be where things are going, where your local model will be just as much intelligence as you need and will be just as powerful as you need, but it won't be as fast as you need, and you won't be able to do as much concurrently. And that's where I think like the value of a lot of these labs and providers out there are going to be. And you're starting to see OpenAI embrace this with their Cerebrus stuff. But I think that's where it needs to go, is like your local intelligence is fine. It's just the speed and performance and scalability that you need third-party providers for. And that means that there's going to be a much more dynamic market out there than there currently is, if the things keep going in this direction. So, I don't know. I'm going to end the stream here. I'm going to let this keep going. Real quick, let's check back in. We're at 88.6% of the context window. It's doing its work. It's sleeping. It's doing downloads now. It's downloading. Let's check the download log. Download log. Unsloth. Downloading the Q8. Yeah. So, that's fun. This has been a fun one. I hope everyone's had fun like following along with this. I sure did. So I'll see you next weekend.